Hello there and welcome to NiteNotes Studio, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we'll wander into one of the most dramatic moments our planet has ever lived through, though no one who walked the Earth at the time would have called it dramatic. To them, it was the end of the world. I'm talking about the day a space rock larger than Mount Everest came barreling down from the heavens and changed everything. Absolutely everything, in ways that still echo through the bones of every creature alive today. Dinosaurs had ruled for more than 150 million years. They were not just the stars of their age. They were the entire cast, the supporting roles, the background extras, the voices in the crowd. They were the thundering footsteps that shook valleys, the shadows that stretched across plains, the calls that echoed through primordial forests. But in one fiery instant, their story was cut short, and life on Earth was forced to improvise something entirely new, something unimaginable. You and I are here because of that accident, that cosmic misstep, that unimaginable stroke of chaos that rewrote the rules of existence itself. Tonight, we'll walk slowly, carefully through what the Earth became after the impact. What it looked like when the dust finally settled, what it smelled like when the air was thick with sulfur and ash, what survived against all odds, what didn't make it through the long darkness, and how from the ashes of that nightmare, something very familiar to us began to emerge. This is not just a story about dinosaurs disappearing. It's a story about resilience, about transformation, about how our world was forged in fire and darkness, and somehow found its way back to light. But before we begin this journey into Earth's deep memory, let me ask you something small, just between us. Where are you listening from right now? Is it morning for you, the sun pushing through your curtains as the world stirs awake, birds beginning their chorus, the day full of promise? Or is it night, with the sky dark and your thoughts winding down, the quiet settling around you like a blanket? Wherever you are on the clock, whatever time zone you inhabit, pause for a moment and picture that world long ago. The ground trembling beneath massive feet, the air darkening with debris that shouldn't be there, creatures that had never known fear suddenly staring at a sky they didn't understand, at a brightness that shouldn't exist, at a doom they couldn't comprehend. Strange, isn't it? How one event 66 million years ago can echo right into this quiet moment we're sharing. And if you find this slow exploration soothing or intriguing or just a pleasant way to drift at the end of your day, I'd be grateful if you tap that like button or maybe subscribed. It helps this little corner of calm reach others who might need it, who might be searching for something gentle in a world that often feels too fast, too loud, too overwhelming. And perhaps someone else out there, sleepless and searching, will stumble into this gentle detour through science and story and find it just enough to ease them toward rest, toward peace, toward a different way of thinking about time and existence. Now, let's begin carefully, like we're stepping into a vast museum after hours. The lights are low, the air is still, and the exhibits are not bones in glass cases, but living scenes, breathing moments from deep time. The Earth itself is unfolding around us, revealing secrets it has held for millions upon millions of years. Somewhere in that darkness, 66 million years ago, a rock fell from space. It struck what is now the Yucatan Peninsula in Mexico, with a force of billions of atomic bombs, with an energy release that defies human comprehension. It carved a crater more than 100 miles wide and more than 12 miles deep, a wound in the planet's flesh that would take millennia to heal. The impact released so much energy that the air itself turned to fire, that rock vaporized into plasma, that the very fabric of the atmosphere was torn apart. That is the moment we're stepping into, though we won't stay with the impact too long. The blast is the beginning, the opening note of a symphony of destruction. But what fascinates us tonight is everything that came after. The strange and quiet hours, days, months and years when the planet had to reckon with what had happened. In those first hours, dust, vaporized rock, and molten droplets were blasted high into the atmosphere, some pieces reaching beyond the edge of space itself before falling back. Imagine the sky lit not by stars, but by countless burning fragments falling back down like a rain of meteors, like the heavens themselves were collapsing. Whole forests caught fire, stretching across continents in waves of flame that moved faster than any creature could run. Animals fled, though there was nowhere safe to flee to, no refuge that could shelter them from what was coming. The oceans boiled at their edges, great waves spreading outward from the impact zone, walls of water taller than mountains rushing across shallow seas. But what's remarkable isn't just the violence of that day, isn't just the immediate destruction that erased everything within hundreds of kilometers. It's the stillness that followed, the eerie calm that descended when the initial chaos had passed. Imagine waking after the chaos, if you survived, to a world where the sun did not rise, where the concept of morning had lost all meaning, where the air smelled of sulfur and ash, acrid and choking, where daylight was dimmer than twilight had ever been, and where silence stretched for miles, broken only by the occasional groan of settling earth or the hiss of cooling rock. That silence is where our story rests tonight, in that profound quiet that followed the loudest moment Earth had ever known. Because the Earth after the impact was not immediately dead, but it was profoundly altered in ways that would determine which species survived and which perished. As the dust spread high into the stratosphere, it wrapped the globe in a shroud, a veil that would not lift for years. Sunlight could not pierce it easily, and what light did filter through was weak, sickly, insufficient. Temperatures began to fall as the planet's heat radiated into space with nothing to trap it. Photosynthesis, the process plants used to turn light into life, halted almost everywhere across the planet. The dinosaurs that survived the initial blast found themselves in a world without food, a world where the green that had sustained them for millions of years was turning brown and gray and black. Leaf eaters starved first, their massive bodies requiring hundreds of pounds of vegetation each day to function, followed by the predators who depended on them, who watched their prey dwindle and weaken until there was nothing left to hunt. Insects scurried through the ash, some thriving on the abundance of death, others vanishing as their food sources disappeared. Mammals, small and often overlooked, huddled in burrows, living off seeds, roots, and anything they could gnaw through. It's tempting to imagine that the end was quick, but it was not. For weeks, months, even years, Earth stayed in this twilight, this half-world between life and death. Fires burned themselves out eventually, the smoke joining the dust above, creating layers upon layers of darkness. The oceans grew colder and acid rain fell, turning rivers and lakes into hostile pools that burned the gills of fish and the skin of amphibians. You might wonder what it would have looked like to stand on that planet, to open your eyes and gaze around at the transformed world. The first thing would be the darkness, not pitch black, but dim, like standing beneath heavy storm clouds that never lifted, that never broke to reveal blue sky. The second would be the air itself, thick, gritty, hard to breathe, each inhalation carrying particles that scratched and burned. The world smelled like burning stone, sharp and sour, with every inhale carrying reminders of the catastrophe, of forests that had burned, of rock that had vaporized, of an ocean that had boiled. The third would be the absence of sound beyond the whisper of falling ash. Forests gone quiet, their birds vanished, their rustling leaves burned away. Rivers slowed by ash and debris. The cries of creatures fewer and fewer each day, until the silence became almost absolute. If you were lucky enough to survive, it must have felt like standing in the ruins of a world that was not coming back, like being the last witness to a dying planet. And yet, deep below the soil, Seeds waited in their protective shells, dormant but not dead. In the dark waters, small fish swam through murk and silt, somehow finding enough oxygen to continue. Life, fragile but stubborn, had not given up, had not surrendered to the darkness. Scientists call this period the aftermath of the Cretaceous-Paleogene extinction event, but that phrase doesn't quite capture the scale of what happened, doesn't convey the sheer magnitude of loss. More than 70% of all species vanished, entire families of creatures erased from existence as if they had never been. The dinosaurs, save for a small lineage that would become modern birds, were gone. The great marine reptiles that had ruled the oceans, the flying pterosaurs that had dominated the skies, the ammonites that had filled the seas for hundreds of millions of years, all gone, all silenced. Yet here in the shadows, in the forgotten corners, mammals began to stir. Small, furry, adaptable mammals that most dinosaurs had never even noticed. They had lived in the corners of the dinosaur world, unnoticed, unimportant, barely worth acknowledgement. But after the asteroid, those corners became center stage. With the giants gone, space opened up, enormous amounts of ecological space to eat, space to grow, space to imagine new shapes, new strategies, new ways of being. Out of that opening, eventually, much later, would come us, would come primates, would come the lineage that leads directly to every human being alive today. And that is why we begin this journey, not because the asteroid ended the age of dinosaurs, but because it created the world that would one day welcome humans. It forced Earth into a reset, harsh and unforgiving, yes, but also creative, also full of possibility. From the ashes of forests came new kinds of plants, species that had been minor players suddenly becoming dominant. From the burrows of mammals came diversity, an explosion of forms and strategies. From oceans scoured of their rulers came fresh waves of evolution, new creatures filling empty niches. The Earth after the impact was not just a graveyard, not just a monument to what had been lost. It was a workshop, a laboratory of evolution, a place of silence, then whispers, then voices rising again, slowly building toward the chorus of life we know today. So settle in as we walk slowly through those days and years, through the long recovery that stretched across millions of years. We won't rush because Earth didn't rush either. It took millions of years to recover fully, to rebuild ecosystems from the ground up, to stabilize the climate, to repopulate forests and seas with the incredible diversity we see today. Every step of that journey holds stories, some tragic, some surprising, all remarkable in their own way. And as we trace them tonight, we'll see not only what happened long ago, but also what it says about our present and our future, about the fragility and resilience that define all life on Earth. Because Earth has been through disaster before, many times across its long history. It has been broken, scarred, and left for dead by cosmic impacts, by massive volcanic eruptions, by sudden climate shifts. But it has also healed, adapted, and flourished again, each time emerging different but still alive, still vibrant. That is the story of our planet, a story of endings and beginnings, of death and rebirth, of catastrophe and renewal. And it begins in the long shadow of a falling star, in the moment when the sky itself became the enemy. It begins quietly, in a way that seems almost peaceful when you consider what was about to unfold. 66 million years ago, Earth spun through its usual rhythm, the same rhythm it had maintained for countless millions of years. The continents sat in slightly different positions than today. The Atlantic Ocean was narrower. India was still an island racing northward toward Asia, but the oceans still rolled with their eternal tides. The forests still whispered in the wind, and the skies were filled with wings, both feathered and leathery. Dinosaurs wandered across plains, swam in rivers, and nested in forests that stretched unbroken for thousands of miles. Some were massive, towering shapes that shook the ground with each step, their necks reaching into the highest branches. Others were no larger than a dog, quick-footed and nervous, darting between ferns and fallen logs. Birds, already descended from their dinosaur ancestors, glided overhead, calling to one another in voices that might sound oddly familiar to us if we could hear them. Crocodiles slid into rivers, their armor unchanged from forms that had existed for millions of years. Turtles sunned themselves on logs and rocks, patient and ancient. Insects droned in the heat, their buzzing filling the air with the sound of summer. To the creatures living then, it was just another day, another morning of eating, hunting, resting, raising young, the endless cycle of survival that had continued for so long. Nothing on Earth gave the slightest hint that this ordinary stretch of time would be the last of its kind, that normalcy was about to end forever. But above them, far beyond their sight, beyond the blue vault of the sky, a rock was falling through the darkness of space. Not a pebble, not a boulder, but a mountain hurled through space by forces that had shaped it billions of years ago. This asteroid had been orbiting the sun for millions of years, perhaps since the formation of the solar system itself, nudged little by the gravitational pulls of planets, until its path intersected perfectly, terribly, with Earth. It measured about 10 kilometers across, larger than Mount Everest, a chunk of rock and metal that had traveled through the cold darkness for an eternity. And it traveled at more than 20 kilometers per second, moving so fast that the human mind can barely comprehend such velocity. That speed is hard to grasp, almost impossible to imagine. In the time it takes you to blink your eyes, the rock covered the distance of several football fields. The dinosaurs could not see it coming, had no way to perceive the doom approaching from above. They had no telescopes, no warnings, no way to understand that the universe had set in motion an event that would end their reign. To them, the sky was the same as it always was, wide and bright, painted with drifting clouds, beautiful and unchanging. But somewhere above, invisible to their eyes, the fate of their world was sealed, written in trajectories and velocities and the cold mathematics of orbital mechanics. The moment of impact came with no prelude for those on the ground, no warning, no chance to prepare. In what is now the Yucatan Peninsula of Mexico, in shallow tropical waters teeming with life, the asteroid struck. The Gulf of Mexico at the time was dotted with reefs and teeming with fish, with ammonites and marine reptiles, with countless forms of life that had evolved over millions of years. In one instant, all of that life was erased, vaporized, turned to plasma and scattered across the stratosphere. The energy released by the collision was greater than billions of nuclear bombs combined, a release of energy so vast that our largest modern weapons seem like firecrackers in comparison. The rock punched a crater more than 100 miles wide and 12 miles deep, excavating rock that had been buried for billions of years. The ground heaved like a liquid, shock waves raced outward through the crust faster than sound, and water was thrown into the sky higher than any mountain on Earth. The ocean itself seemed to leap in terror, displaced by the sudden cavity, by the energy that turned everything it touched into vapor and fire. The blast vaporized rock, soil, and water into glowing plumes that shot beyond the atmosphere, creating a crown of debris that momentarily encircled the planet. For a moment, a brief instant that seemed to stretch forever, the Earth itself shuddered like a bell struck too hard, ringing with the impact. If you could have seen it from space, from some impossible vantage point beyond the atmosphere, the sight would have been both mesmerizing and horrifying, both beautiful and terrible in equal measure. A brilliant flash of light, brighter than the surface of the sun, spread across the impact site and illuminated the planet. A fireball grew and expanded, glowing orange and white with temperatures that exceeded anything found naturally on Earth's surface. Rings of debris blasted outward in perfect circles, glowing arcs that spread across the atmosphere like ripples in a pond, except these ripples carried devastation with them. From orbit, Earth would have looked wounded, like a living thing that had been struck a mortal blow. A blue and green sphere suddenly marred by a burning wound, by a point of light that pulsed and expanded, and then slowly began to fade as the debris climbed higher into the atmosphere. For the creatures on the surface, there was no time to understand, no time to react, no time to run or hide. Anything within hundreds of kilometers was obliterated instantly, vaporized by heat and pressure that exceeded anything in their evolutionary experience. Forests turned to flame in microseconds, their wood vaporizing before it could burn. Rivers boiled away, their water turned to steam that rose into the expanding fireball. Animals caught in the open stood no chance at all. It was as if the entire region had been dropped into the heart of a volcano, except this was worse, hotter, more violent, more absolute. The shock waves did not stop at the crater, did not respect the boundaries of the impact zone. They raced across the planet's crust, traveling through solid rock at impossible speeds, triggering earthquakes stronger than anything in human history, stronger than anything most species had ever experienced. Mountains shook so violently that their slopes collapsed in massive landslides. Valleys cracked open, releasing gases from deep within the earth. Landslides roared down slopes, carrying millions of tons of rock and soil. In oceans far from the impact, tsunamis rose higher than skyscrapers and surged toward distant shores, walls of water that seemed to reach toward the sky itself. Imagine standing on a beach thousands of kilometers away, far from the impact site, believing yourself safe. You hear a strange roar on the horizon, a sound like nothing you've ever heard. And then you see it, a wall of water rushing toward you faster than you could run, faster than most creatures could flee, a wall hundreds of meters high that blots out the sky. Coastal ecosystems were swept away in minutes, everything that lived near the shores erased by water that should never have reached so high, that should never have been so powerful. Creatures that had never seen waves higher than a few meters suddenly faced walls of water hundreds of meters tall, water that picked up everything in its path and carried it inland for miles before retreating and leaving behind only devastation. Above all this chaos, above the earthquakes and tsunamis, the sky began to rain fire in a way that sounds like mythology but was terribly, horribly real. When the asteroid hit, it threw countless fragments of molten rock into space, debris that arced high above the atmosphere, some pieces reaching altitudes where the Earth's gravity barely held them. These pieces, glowing white-hot, then fell back down across the globe, some landing thousands of miles from the impact site. Re-entering the air at tremendous speeds, they glowed white-hot, heated by friction with the atmosphere, turning the sky into a broiler, into an oven that cooked everything below. Forests thousands of kilometers from the crater burst into flames as the rain of fire swept across them, as burning debris fell like meteoric rain. Animals far removed from the blast zone, animals that might have thought they were safe, found themselves surrounded by wildfires that ignited without warning. Smoke choked the air, turning day into a murky twilight. Flames leapt from treetop to treetop with terrifying speed, moving faster than most animals could run. And whole landscapes burned at once, not one fire but thousands, all ignited within hours of each other. Some scientists believe that nearly every forest on Earth caught fire in those hours, leaving behind a planet smothered in ash, leaving behind a landscape of blackened stumps and gray soil. The heat itself was enough to kill, even without the flames. The atmosphere, superheated by the returning debris, baked the surface. Temperatures soared for hours, roasting creatures in the open even if they escaped the flames. Only those sheltered underground, in water deep enough to insulate them, or in deep burrows had any chance at all. Even then, survival was not guaranteed, not even close. Streams dried up as water evaporated, soil baked hard as brick, and oxygen dwindled in enclosed spaces as fires consumed it. Survival came down to luck, to location, and to sheer resilience, to being in the right place at the right time with the right adaptations. And yet, even in this horror, even in this apocalyptic landscape, not everything perished at once. Life clung on with remarkable tenacity. Crocodiles in rivers, shielded by water that absorbed much of the heat, clung on by submerging themselves completely. Mammals in burrows pressed deeper into the soil, huddling in darkness, their small bodies requiring less oxygen than the giants above. Seeds buried in the ground remained intact, their tough coats protecting the life within, waiting for conditions that might never return. Insects, especially those that could feed on decaying matter, thrived in the chaos, their populations exploding as they fed on the abundance of death. But for the towering dinosaurs, for the ones that had ruled the world so long, that had seemed so invincible, this was the beginning of their end. The impact did not kill them all instantly, did not strike them down in a single moment, but it set in motion a chain of disasters that would erase them from the face of the earth. After the first hours, as the immediate violence began to subside, the sky darkened in a way that was even more ominous than the fire had been. The dust and soot thrown up by the impact began to spread through the atmosphere, carried by winds, distributed globally within days. Sunlight dimmed to a sickly twilight, to a perpetual dusk that would last for years. Photosynthesis stopped as plants could no longer gather enough light to convert carbon dioxide and water into energy. Plants withered, starving the herbivores that fed on them, who in turn starved the predators that fed on the herbivores. With fewer herbivores to hunt, the predators soon followed, their massive bodies demanding calories they could no longer find. The food chains that had supported vast ecosystems collapsed like dominoes, each level falling in turn. In the oceans, the situation was equally dire. Plankton died off in massive numbers, their tiny cells unable to photosynthesize, breaking the base of the marine food web. Creatures that had thrived in the seas for millions of years suddenly found themselves in barren waters, in oceans that could no longer support them. Think of how strange the world must have felt then, how disorienting and terrifying. For millions of years, it had been noisy with life, filled with the footsteps of giants, the buzzing of insects, the calls of birds, the rustling of leaves in forests that stretched for thousands of miles. Now it was quiet, eerily quiet. The great forests had burned to ash. The skies were dark. The air was colder with each passing day. Those who survived did so in silence, scurrying from shelter to shelter, hiding in whatever refuge they could find, feeding on scraps of what had been. The world had changed overnight, and though some creatures endured, though life held on in pockets and corners, the age of dinosaurs was slipping away like water through cupped hands. The rock that fell from the sky did not just scar Earth's surface or kill millions of individual creatures. It rewrote the story of life itself, changed the trajectory of evolution in ways that would echo for millions of years. Without that impact, dinosaurs might still rule today, might still be the dominant form of large animal life on every continent. Mammals might still be tiny, furtive creatures hiding in shadows, never getting their chance. The asteroid ended one age and opened the door for another, though that door would take a long time to fully open. From the silence that followed, from the darkness and cold, new voices would eventually rise. But in those first days, all that mattered was survival, hour by hour, day by day, with no guarantee that tomorrow would come. The day the sky fell was not the end of the world entirely, but it was the end of the world as it had been known for more than 150 million years. And as the fire smoldered, as the dust spread higher and higher into the stratosphere, as the temperatures began their slow descent, the true aftermath was only beginning, the long test of endurance that would determine which lineages continued and which joined the dinosaurs in extinction. The planet did not rest after the impact, did not pause to catch its breath or assess the damage. The rock that had torn into the Yucatan had left more than a scar in the crust, more than a crater that would slowly fill with sediment over millions of years. It had unleashed fire across continents in a way that seems almost impossible to comprehend. Even as the crater cooled, even as molten rock settled back into an uneasy stability, the rest of the Earth burned with an intensity that defied imagination. Forests that had stretched unbroken for thousands of miles, that had provided homes for countless species, were suddenly sheets of flame reaching toward the darkening sky. What had once been green and shaded and alive, filled with the sounds of animals and the rustle of leaves, was now black and orange, crackling with intense heat, collapsing as trees fell like matchsticks, sending sparks into the already darkened sky. The rain of molten debris that had circled the globe returned in waves, like meteor showers that never ended, each fragment like a tiny meteor igniting the air as it fell, starting new fires wherever it landed. Entire landscapes caught fire at once, not one fire spreading gradually, but thousands of fires starting simultaneously. There was no single wildfire to run from, no direction that offered safety. The air itself was hot enough to set leaves smoldering without direct flame, to ignite dry grass through sheer radiation, to make breathing itself dangerous. Even creatures that fled to rivers and lakes, seeking refuge in water, found themselves surrounded by steam as water boiled at the edges, and oxygen grew scarce in the superheated air. Imagine what it must have been like for those who survived the first blast, for the creatures unlucky enough to witness what came after. A hadrosaur, perhaps, one of the duck-billed dinosaurs, wandering the edge of a forest miles from the impact site, far enough to survive the initial shock. Its skin shivered as the ground quaked beneath its feet. Its ears caught the low rumble from far away, a sound unlike anything in its experience. Then the sky brightened, not with sunlight but with a sickly glow, and minutes later the forest around it lit like a torch, flames erupting from the canopy as if the trees themselves had become fuel waiting for a spark. Instinct drove it to run, to move away from the flames, but where could it go? Every direction carried the smell of smoke, thick and choking. Every gust of wind carried sparks that landed on its skin, burning. Creatures that had lived their entire lives under the shelter of trees, that had evolved in forests and knew nothing else, now faced the collapse of their only home. The firestorm was global in a way that's hard to truly grasp. Studies of ancient charcoal and sediments tell us that plants across the world burned almost at once, within days of the impact. The heat, radiating back down from re-entering debris, raised ground temperatures enough to ignite anything that could burn, from the tropics to the temperate zones. Grasslands, forests, even damp swamps that should have been protected dried out and flared into flame. It wasn't only the land that burned. Out at sea, floating mats of vegetation, islands of plant life that supported their own ecosystems, went up in smoke, releasing clouds of ash that mixed with the dust already hanging in the sky like a funeral shroud. Fish swam in waters now shadowed by soot, their surface littered with falling ash that choked their gills and poisoned the water. And yet, amid this destruction, amid what seemed like total annihilation, survival still depended on chance, on random factors that no creature could control. Some places escaped the worst of the fires through sheer luck. In deep valleys, rivers shielded patches of green, the water absorbing enough heat to prevent complete combustion. In wetlands, Soggy ground slowed the flames, created fire breaks that saved small pockets of vegetation. In caves, darkness and isolation provided refuge from the heat and smoke. Small mammals huddled underground, their tiny bodies pressed together for warmth as the surface world collapsed in fire and smoke. Insects burrowed into the soil or hid beneath bark that didn't ignite. Seeds lay dormant in the ground, sealed away from the searing heat by layers of soil and their own tough coats, waiting for a future that must have seemed impossible. It was not mercy that decided who lived and who died, but randomness, chance, the lottery of location and adaptation. For weeks, the fires raged across the planet, fed by forests that had accumulated biomass for millions of years. Their smoke thickened the atmosphere even more than the dust had, turning daylight into a dim glow that barely qualified as light. Ash fell like black snow, coating rivers and lakes, suffocating fish and insects alike, covering every surface with a layer of gray that marked the catastrophe. Rain mixed with soot to fall as dark sludge, staining everything it touched, creating a layer that would be preserved in the geological record forever. The earth's smell was acrid, heavy with the scent of burning wood and sulfur and decay, a smell that would linger for years. Creatures that had escaped flame still struggled with the poisoned air, coughing in ways we can only imagine, struggling for breath in an atmosphere thick with particulates and toxic gases. When the fires finally began to die, when the last flames flickered out for lack of fuel, the world that remained was unrecognizable from what had been just weeks before. Charcoal lay where forests had been, thick layers of it that would become coal in millions of years. Rivers were clogged with debris, with fallen trees and ash and the bodies of creatures that had sought refuge in water. Grasslands were stripped bare, their soil exposed and vulnerable to erosion. Entire regions were silent in a way that went beyond mere quiet. No birds calling because there were no birds left to call. No insects buzzing because their populations had crashed. No animals moving through undergrowth that no longer existed, that had been reduced to ash and dust. Even the soil was changed, scorched to sterility in places, its organic matter consumed by fire, unable to support regrowth until time and rain could slowly heal it and bring back the nutrients needed for life. The global firestorm was not just a side effect of the asteroid, not just collateral damage. It was the first chapter of the longer extinction, the opening act of a catastrophe that would play out for years. By stripping away vegetation, it left herbivores starving with nothing to eat. By darkening the sky even more than the dust alone would have, it cut off photosynthesis even more completely. By filling the atmosphere with soot, it prepared the planet for its long winter, for the cold and darkness that would test every survivor to their limits. The fire was both an end and a beginning, a passage into the deeper catastrophe of darkness and cold that followed, a transition from one kind of hell to another. Think of the sheer scale of it, try to wrap your mind around the magnitude. Today, a wildfire that sweeps through a forest is devastating enough, is considered a major disaster. A single fire can last weeks, can send smoke across entire regions, can choke cities hundreds of miles away with its haze. Multiply that by 1,000, by 10,000, and stretch it across every continent, and you begin to approach what Earth experienced then. There was nowhere untouched, no horizon that did not glow red at some point, no air anywhere on the planet free of smoke. The entire biosphere became one vast furnace, one planetary-scale fire that consumed everything that could burn. And still, remarkably, impossibly, life persisted in corners and crevices. Crocodiles sank deeper into rivers, their armored bodies enduring heat that would have killed other creatures, their slow metabolisms allowing them to wait out the worst. Turtles buried themselves in mud at the bottom of ponds and lakes, their shells protecting them, their ability to slow their breathing helping them survive in low-oxygen environments. Amphibians clung to moist refuges where flames could not reach, to springs and seeps and underground streams. Mammals gnawed whatever roots they could find, their teeth cracking open the hard shells of seeds, their determination to survive stronger than the fire above. Even some birds, descended from small feathered dinosaurs, managed to survive by feeding on the few scraps that remained, by adapting their behavior to the changed world. Each survivor carried forward a spark, not of fire, but of continuity, of the unbroken chain of life. Each was a thread in the fabric of life that refused to unravel completely, that held on against all odds. When the smoke finally began to thin, when the fires burned out from lack of fuel and the ash settled into thick layers on the ground, Earth entered a silence deeper than before, a quiet that went beyond the absence of sound. The flames had consumed more than forests and grasslands. They had consumed stability, had destroyed the ecological frameworks that had supported life for millions of years. What followed was a planet stripped bare, scoured clean, ready for the next calamity, which would be the long winter of darkness that would test the survivors even further. But before that silence fully arrived, before the dust settled into its thickest blanket and the cold began its inexorable descent, the memory of fire lingered in every corner of the globe. Charcoal buried in soil would remain there for millions of years, a black layer marking the catastrophe. Blackened trunks standing like monuments, testament to forests that once were. Air still heavy with the scent of smoke, even as the flames died. For those who lived through it, it was not only the memory of flame that haunted them, but the knowledge that nothing would ever be the same again, that the world they had known was gone forever. And so the world, scorched and trembling, stripped of its green mantle, turned slowly toward its next trial, toward the cold and darkness that would define the years to come. When the asteroid struck with its unimaginable force, the world shuddered in ways no living creature had ever experienced in all the millions of years of evolution that had preceded that moment. The impact itself was a moment of unimaginable violence, a release of energy that exceeded anything in the planet's recent history. But the story did not end with fire and falling debris, with the immediate destruction that erased everything near the impact site. The Earth is not a silent partner in catastrophe, not passive in the face of such violence. It responds with its own power. It groans under the stress. It shifts and cracks. It sends out ripples that race across continents and seas, ripples that carry destruction far beyond the initial blast zone. Those ripples were not gentle undulations, not subtle vibrations. They were shock waves of incredible power, seismic energy that traveled through solid rock as if it were water. And they carried destruction far beyond the blazing crater, far beyond the immediate impact zone. The rock had slammed into shallow water with such force that it created effects that would be felt globally. It blasted a cavity more than 100 miles wide in less than a second, excavating rock and water and everything in between. The crust beneath it buckled under pressures it was never meant to withstand, fractured in patterns that would be visible for millions of years, and heaved upward before collapsing inward again in a complex dance of destruction. That movement alone, just the initial deformation of the crust, released enough seismic energy to rival the largest earthquakes in Earth's history. Earthquakes with magnitudes that make the strongest modern quake seem like aftershocks, like minor tremors barely worth mentioning. If you've ever felt the ground tremble beneath you during a small quake, you know how unsettling it feels, how it shakes your confidence in the solidity of the Earth itself. Now imagine that sensation amplified beyond comprehension, beyond anything evolution had prepared any creature to experience. Not for seconds, but for hours, rolling outward in waves that seemed endless, shaking mountains until their peaks crumbled, rattling valleys until their walls collapsed, and stirring the seas into chaos unlike anything witnessed before or since. Around the Gulf of Mexico, within the immediate vicinity of the impact, the ground would have convulsed violently in ways that defy description, splitting open in massive fissures, hurling debris hundreds of meters into the air, sending cliffs crashing into the water in avalanches of rock and soil. Forests already scorched by falling fire found their roots torn loose by waves of trembling earth, trees toppling like dominoes in patterns that stretched for miles. Rivers sloshed back and forth in their channels like water in a bathtub, spilling over banks, flooding plains, then draining back in sudden surges that left fish stranded and gasping. Animals that had managed to survive the fires, that had found shelter from the heat, now stumbled in confusion as the very ground beneath them betrayed their balance, as the earth that should have been solid became liquid and unpredictable. Those too close to the epicenter never had a chance at survival, no matter how strong or adaptable they were. They were swallowed by collapsing cliffs, crushed beneath falling rocks the size of houses, drowned in sudden floods that appeared without warning. But the shock did not stop there, did not respect the boundaries of the impact zone or the immediate vicinity. Seismic waves radiated outward through the crust in all directions, circling the entire planet in a matter of hours. Within minutes of the impact, quakes shook lands thousands of kilometers away, lands where creatures might have believed themselves safe from whatever had happened. In what is now North America, entire forests quivered as the ground beneath them rolled in waves, trees toppling like matchsticks, crushing everything beneath them. Across the Atlantic, waves of vibration rattled the coasts of Africa and Europe, causing landslides and avalanches in regions that had never experienced such violence. Even on the far side of the world, as far from the impact as geography allowed, the tremors arrived, weaker certainly but still unsettling, still powerful enough to topple unstable formations, as if the planet itself were groaning from the blow it had just endured, crying out in pain that could be felt everywhere. In the oceans, the consequences were even more dramatic, even more catastrophic than the land-based destruction. The sudden displacement of water, the instant removal of countless cubic miles of ocean, triggered tsunamis taller than skyscrapers, waves of unimaginable power. Waves hundreds of meters high surged outward from the Gulf in all directions, racing across the seas faster than a jet plane, traveling at speeds that nothing could outrun. Coastal regions thousands of kilometers away, places where the sky had darkened but the immediate danger seemed to have passed, found themselves swallowed hours later when walls of water arrived without warning, when the ocean itself rose up like a living thing intent on consuming the land. Imagine being a creature on a shoreline half a world away from the impact. Imagine being one of the pterosaurs, those great flying reptiles, perched on a rocky cliff scanning the horizon for fish as you had done every day of your life. Hours after the sky had burned, after the fire rain had passed, you might have thought the worst was over. And then you see it on the horizon, at first just a line, then growing, rising, becoming a wall of water that blots out the sky itself, a wall that seems impossible, that shouldn't exist. The ocean smashing against rock with a force that pulverizes stone, carrying everything away, sweeping inland for miles, erasing everything in its path. Whole ecosystems vanished beneath those waves in seconds, ecosystems that had taken millions of years to develop. Estuaries where fresh and salt water mixed, mangroves that protected coastlines, beaches where turtles laid their eggs, all scoured clean in a single sweep, all erased as if they had never existed. The tsunamis carried evidence of their reach that we can still find today millions of years later. Geologists studying rocks from this period find deposits of disturbed sediments far inland, layers of rock and sand thrown out of place by waves that had no business reaching so far, that defied all normal patterns. In Texas, in Florida, in regions once distant from the crater itself, traces of ancient tsunami debris mark the scale of the ocean's fury, mark the reach of destruction. The impact did not just scar one region, did not just affect the Gulf of Mexico. It reshaped coastlines across the globe, redrew the boundaries between land and sea in ways that would influence geography for millions of years. As the seismic energy continued to ripple through the planet's crust, aftershocks shook the planet for weeks afterward, each one a reminder that the Earth had not yet settled, had not yet absorbed the violence done to it. Fault lines slipped as accumulated stress was released. Volcanoes may have stirred, their magma chambers disturbed by the sudden jolt, though whether this triggered eruptions is still debated by scientists. Geysers erupted, releasing steam and water into already darkened skies. The Earth groaned under the strain, releasing its anger in fits and starts long after the initial blow, like a wounded animal that cannot find rest. Creatures that had managed to find shelter from fire, that had hidden in caves or burrows or deep water, found no peace in the days that followed the impact. The ground refused to hold still, refused to provide the stability that all terrestrial life depends on. For the dinosaurs, creatures accustomed to stable ground beneath their heavy bodies, creatures whose very size depended on predictable physics, the quakes must have been terrifying beyond measure. Imagine a massive sauropod, one of the long-necked giants weighing tens of tons, swaying as the ground rolled beneath it like water, its legs struggling to balance on soil that shifted and heaved like liquid. For smaller animals, the tremors were no less dangerous, no less deadly. Burrows collapsed, trapping mammals that had sought refuge underground, burying them alive. Birds nesting in cliffs saw their perches crumble, sending eggs and nestlings plummeting to their deaths. Crocodiles in rivers were swept away as banks collapsed, as the channels themselves changed course in minutes. Survival was no longer about strength or speed or intelligence. It was about luck, about being in the right place at the right time when the Earth decided to convulse again, about random chance that no adaptation could fully protect against. And yet, amid this destruction, amid what seemed like the total breakdown of the physical world, there were survivors. Life is stubborn, remarkably stubborn, unwilling to yield entirely even to forces this great. Some burrows held firm, their construction or location protecting them from collapse. Some cliffs resisted collapse through the strength of their stone. Some valleys absorbed the waves instead of amplifying them, their shape protecting what lay within. And in these pockets, these random refuges, small creatures endured, though their world was altered forever, though nothing would ever be quite the same. The shock waves were more than physical disruption, more than just shaking and breaking. They were environmental catastrophes in their own right. The quakes and tsunamis stirred up sediments from the ocean floor, releasing carbon dioxide that had been locked away, releasing methane from deposits that should have remained stable, releasing other gases that changed the chemistry of the water. Toxic chemicals entered rivers and lakes as the earth cracked open and released what had been buried. Ash mixed with water to form acidic slurries that killed fish and plants alike, that poisoned entire watersheds. Entire freshwater ecosystems collapsed as lakes turned poisonous, as streams clogged with debris, as wetlands drowned under sediment or dried up when their water sources were cut off by landslides. For creatures that depended on clean water, that needed specific conditions to survive, this was another lethal blow on top of the fire and darkness. But perhaps most unsettling of all, most psychologically disturbing if we can imagine the mental state of creatures facing these conditions, was the silence that followed each quake. Imagine standing in a charred forest, smoke still rising in thin columns. the air still thick with heat even days after the fires had passed, and then feeling the ground tremble beneath your feet. Trees groan under the stress, their burned trunks creaking. Rocks fall from cliffs with crashes that echo across the emptiness. Animals cry out in fear and confusion. Then, after minutes of chaos that seem to last forever, the shaking stops. For a moment, all is still, eerily still, as though the world is holding its breath, as though the earth itself is pausing to gather strength, waiting for the next convulsion, wondering if this is truly the end or just another pause in an endless catastrophe. And then, just as you begin to think it is safe, just as your muscles begin to relax and your breathing begins to slow, another aftershock arrives, rolling through the ground like an invisible wave, reminding you that stability has vanished, that the world you knew is gone. That cycle of tension and release, of hope and fear, must have defined the days and weeks after the impact for any creature aware enough to experience it. The fossil record bears witness to this turmoil, preserves evidence of these chaotic days. In rock layers from that time, scientists find deposits of jumbled sediments, layers that should be neat and orderly, but instead are mixed and chaotic, signs of sudden underwater slides where the seafloor simply gave way, signs of repeated earthquakes that shook sediments before they could settle, and chaotic layering consistent with repeated disturbances, with a world that wouldn't hold still long enough for normal geological processes to resume. In some places, fossilized fish lie in silt that buried them alive, their bodies preserved in death postures that show they were caught mid-swim as waves swept them inland, and then retreated, leaving them stranded. In others, marine shells are found far above where they should be, sometimes hundreds of meters above sea level, carried by tsunamis to heights they could never reach on their own, deposited in layers that mark the high water marks of ancient catastrophe. These are not quiet deposits of gradual change, not the normal slow accumulation of sediment. They are the fingerprints of catastrophe written in stone, preserved for millions of years as testimony to what happened. For humans living millions of years later, for us trying to understand these events from our comfortable distance in time, it is hard to grasp what global shaking would feel like, hard to truly comprehend the scale. The strongest recorded earthquake in modern times reached a magnitude of about 9.5, the Chilean earthquake of 1960, and it was devastating across a large region. The Chicxulub impact may have released seismic energy equivalent to a magnitude 11 or 12, something far beyond anything in our experience or our measurement scales, something that would make the worst earthquakes we've ever recorded seem minor by comparison. Buildings would not just crumble under such forces. Entire landscapes would rearrange themselves. Mountains would lose their peaks. Valleys would close or open. Coastlines would be redrawn in hours. And though no human eyes witnessed it, though we can only reconstruct it from evidence, the scars remain in the rocks all around the world, silent reminders of the day the earth convulsed like never before. The shock waves also played a crucial role in shaping the crater itself, in creating the structure that would be buried and preserved for millions of years. When the asteroid struck, it created a temporary cavity far larger than the final crater, a void that couldn't be sustained. The ground rebounded upward in the center, forming a central peak that rose kilometers into the air in just minutes, a mountain created in seconds. That peak then collapsed outward, unable to support its own weight, leaving a ringed structure, concentric circles of raised rock. This complex crater design, familiar from other impact sites around the solar system but on a far greater scale here, was the direct result of seismic energy moving through the crust in waves, of the Earth trying to heal its wound but not quite succeeding. Today, the buried remains of those rings can still be detected beneath the Yucatan, using gravity measurements and seismic surveys, a frozen memory of the planet's moment of upheaval, a scar that will remain for billions of years. As days passed, and the quakes gradually lessened in frequency and intensity, as the aftershocks became less frequent, the Earth began to settle into its new configuration. But the damage was done, irrevocably done. The crust had shifted in ways both subtle and dramatic. Coastlines had been redrawn by tsunamis and by the settling of the land. Ecosystems had been erased, their carefully balanced relationships destroyed. And above it all, dominating everything, the skies remained dark, filled with dust and ash that blocked out the sun. The shock waves had done more than shake the ground. They had shaken the foundation of life itself, ensuring that even in places far from the crater, even in regions that had escaped the fire, no creature could escape the consequences of that single terrible day. And still, this was not the end of the catastrophe, not the final chapter. The fires had burned. The shock waves had rolled across the planet. But the dust was only beginning to show its power, was only beginning to reveal how it would reshape the world. The Earth was heading into a night that would last not hours or days, but years, a darkness so profound that it would test every survivor to their absolute limits. The shock had passed, the immediate violence was over, but the darkness was still to come, and with it a cold that would make the shaking Earth seem almost merciful by comparison. The shaking finally eased, though aftershocks still rolled across the continents with decreasing frequency, and the oceans continued to slosh with unnatural tides as they sought equilibrium. The fires that had swept across forests and plains with such terrible intensity burned themselves into embers over the course of weeks, leaving behind blackened landscapes that once had been green and alive with the sounds of countless creatures. And in that strange silence after the convulsions and flames had mostly subsided, after the immediate terror had passed, the planet began to breathe in something new, something heavier, something that would change the course of the catastrophe more than the impact itself had. It was the ash, the soot, the fine dust that had been blasted into the sky by the force of the collision, particles so small they could remain suspended for years. If the firestorm had been a scream, a violent cry of destruction, this was the suffocating whisper that followed, spreading slowly, evenly, inexorably until the whole world was wrapped in it like a burial shroud. When the asteroid hit with its tremendous force, it pulverized billions of tons of rock, literally vaporizing ancient limestone and turning it into the finest possible particles, flinging them upward at speeds high enough to launch fragments into space itself. Most of it fell back relatively quickly, re-entering the atmosphere as glowing meteors that set forests ablaze as we've already described. But a fraction remained suspended high above in the stratosphere, particles so fine they could float for years on the slightest air currents. Mixed with this dust was soot from the burning of countless trees and plants, carbon particles from forests that had taken millions of years to grow, droplets of sulfur released from vaporized gypsum deposits, creating sulfuric acid in the atmosphere, and fine particles of glass called spherules, formed when rock was melted and sprayed out as tiny molten beads that cooled into perfect glassy spheres. Together, they formed a cloud that encircled the globe within days, spreading on high-altitude winds, blotting out the sun more effectively than any volcanic eruption ever had. At first, the change in light might have seemed subtle to any creature still alive and aware enough to notice such things. Days dimmed gradually, shadows softened, sunsets lengthened into twilights that seemed to last forever. But soon the dimming grew heavier, more oppressive. What had once been daylight began to resemble dusk, then deep dusk, then something darker still. Plants that reached for the sun, that depended on light for their very existence, found themselves starved of the energy they needed. Leaves turned pale, then yellow, then brown. Stems sagged under their own weight. Flowers failed to open. their petals remaining closed as if waiting for a dawn that would never fully come. And as days turned to weeks, as weeks turned to months, the twilight deepened into something worse, something close to perpetual night. Across the entire planet, from pole to equator, from the highest mountains to the deepest valleys, the sun was veiled behind a shroud of ash and aerosols, and the earth slipped into darkness unlike anything it had experienced in hundreds of millions of years. The air itself became strange, became something other than what air should be. Breathing was no longer the same automatic act it had been before the impact. Ash fell slowly but constantly, coating the ground, the water, the leaves of plants that still clung desperately to life. Each inhale carried grit, fine particles that scratched throats and lungs with every breath. Insects clogged their spiracles, their breathing tubes, struggling to filter out the particles. Fish gasped at water thickened with soot that absorbed oxygen and made respiration difficult. And larger creatures coughed as their airways filled with particles, struggling for breath in an atmosphere thick with ash and suffering. Rain, when it came, was no relief at all, no blessing. The sulfur mixed with water to fall as acid rain, liquid that burned leaves, that stung skin, that poisoned rivers and turned them toxic. Lakes that had once supported thriving populations of fish and amphibians became sour and hostile, their chemistry altered in ways that killed what little remained. For the survivors, the darkness was more dangerous than the flames had ever been, more insidious, more inescapable. Fire was immediate, violent, but finite. You could see it coming, could try to run. But ash was patient, was everywhere, was inescapable. It lingered in the air for years. It spread to every corner of the globe without exception. It seeped into every crack, every nest, every burrow, penetrating every refuge. It did not roar like fire or rumble like earthquakes. It fell softly, silently, relentlessly, until the surface of the planet wore a coat of gray that seemed permanent, that seemed like the new normal. Fossil layers today, millions of years later, still bear this mark clearly. A thin but unmistakable band of clay enriched with iridium, that rare metal that is scarce on Earth but common in asteroids. That line, found in rocks around the globe from Italy to New Zealand to Colorado, is the fingerprint of the ash, the signature of the catastrophe written in stone as clearly as any written record. It is the boundary that marks before and after, the line between two worlds. But in those first days and months after the impact, no creature cared for signatures or geological records or future scientists. What mattered, the only thing that mattered, was survival from one day to the next. The absence of sunlight meant the collapse of photosynthesis, the very engine of ecosystems, the foundation of nearly all life on Earth. Without light, plants died in massive numbers, their cells unable to produce the sugars they needed. Without plants, herbivores starved, their massive bodies demanding food that no longer existed. Without herbivores, predators followed in a domino effect of extinction. The chain unraveled quickly, frighteningly quickly. Insects that fed on decaying matter thrived for a while, their populations exploding as they fed on the abundance of death. But even they began to falter as the supply eventually dwindled. The oceans too dimmed under the shroud. Phytoplankton, the microscopic plants that float at the surface of the seas, that form the absolute foundation of marine ecosystems, could not survive without light. As they died in unimaginable numbers, so did the zooplankton that fed on them, and so on up the chain in a cascade of extinction until fish, marine reptiles, and the great mosasaurs found themselves in barren waters, in oceans that could no longer support them. Imagine standing in that world if you could somehow survive, if you could somehow be there as an observer. You walk through a forest that is no longer green but black and gray, a landscape of death. The trunks of trees are stripped of leaves, standing like skeletal fingers reaching toward a sky that offers nothing. The ground is soft with ash instead of grass, each step raising small puffs of gray dust. The sky above is not blue, will never be blue again for years, but a dim, heavy gray without a visible sun to guide you, without shadows to show direction. The air smells of sulfur, sharp and choking, a smell that never leaves, that permeates everything. You cannot see the horizon clearly because the haze dulls every distance, makes everything seem flat and lifeless. And in the silence, there are no birds calling because the birds are gone or silent. No insects buzzing because their numbers have crashed. No rustle of leaves in the wind because there are no leaves left to rustle. Only the soft, constant fall of ash like snow that never melts, that only accumulates day after day after day. The cooling began almost immediately as sunlight was blocked, as the energy that normally warmed the planet could no longer reach the surface. With sunlight blocked, temperatures dropped steadily and inexorably. Days grew colder as the Earth radiated its stored heat into space, with nothing to replace it. Nights grew colder still, frost forming in regions that had never experienced it. Regions that had been warm and tropical turned chill, their ecosystems completely unprepared for cold. And those already cold became unlivable, became death traps for anything that remained. Ice spread at the poles, growing thicker and reaching farther toward the equator. Frost coated the ash in temperate regions, creating bizarre landscapes of gray ice. Tropical climates shrank toward the equator, compressed into smaller and smaller bands. Animals adapted to warmth found themselves shivering, their bodies unable to cope with the sudden change, unable to adjust quickly enough. Amphibians froze in ponds, their bodies not designed for ice. Reptiles slowed and stiffened, their metabolisms shutting down. Even mammals with their fur and higher metabolisms struggled in burrows and nests that grew colder with each passing day, that offered less and less protection from the chill. The Earth had entered what scientists call an impact winter, a period of cold darkness that lasted for years, that seemed endless to anything living through it. But it was not only temperature and light that changed, not only the obvious factors. The chemistry of the atmosphere shifted in subtle but important ways. Sulfur aerosols reflected what little sunlight reached the atmosphere, deepening the chill even further. Carbon dioxide released from burning forests lingered in the air, waiting to warm the planet once the dust cleared, but for the moment providing no benefit. But for now, for these terrible years, the cooling dominated everything, overriding any warming effects. Ozone was stripped away in the upper atmosphere by chemical reactions, leaving survivors exposed to ultraviolet radiation whenever the sun did manage to pierce the haze, adding another layer of stress. The balance of gases in the air was disrupted in ways both obvious and subtle. A subtle poison that made every breath uncertain, that added one more challenge to an already impossible situation. Life clung on where it could, in whatever refuges offered even the slightest advantage. In the deep ocean, near hydrothermal vents where superheated water poured from cracks in the seafloor, communities of strange creatures survived completely untouched by sunlight, unaffected by what was happening above. Tube worms, clams, and bacteria continued their odd existence in total darkness, as they always had, oblivious to the surface catastrophe, proof that life could exist without sun if it had other energy sources. Underground, seeds endured in a state of suspended animation, waiting with the patience only seeds possess. Mammals in burrows rationed their energy, feeding on whatever roots and insects they could find, their small size an advantage now. Crocodiles sank deeper into rivers, their cold-blooded bodies slowing to near stillness, surviving on the reserves stored in their muscles and the occasional meal that floated their way. And high above, invisible in the gloom, A few lineages of small, hardy birds adapted to feed on seeds and insects managed to persist against all odds, carrying forward the legacy of their dinosaur ancestors into an uncertain future. The ash, though devastating beyond measure, was not infinite. Nothing lasts forever, not even catastrophe. Slowly, gradually over years, it began to settle out of the atmosphere. Particles fell into oceans, forming layers of sediment that would one day tell geologists the story of that time, that would preserve the evidence of what happened. Dust drifted into soil, changing its chemistry, making it more acidic, altering it in ways that would persist for millennia. Some of it washed away in rain, collecting in low valleys and swamps, creating deposits of clay enriched with iridium. But for years, enough remained in the atmosphere to keep the skies dim, to keep the temperatures cold, to keep ecosystems in a state of collapse. Even after light began to return, after the first glimmers of true sunlight started to break through, the scars remained everywhere you looked. Forests regrew slowly, painfully slowly, starting from seeds that had survived underground, seeds that had waited with impossible patience. Grasses pushed through the ash, their green blades startling and beautiful against the gray, signs of hope in a hopeless world. Insects repopulated gradually, feeding on the first sprouts, their populations rebuilding from whatever individuals had survived. Mammals ventured from their burrows more often as conditions slowly improved, sniffing cautiously at the new shoots, testing whether the world was safe again. But the great age of dinosaurs was over, finished forever. Their massive bodies had required too much food, too much energy, and in the years of darkness there was none to spare, not nearly enough. They dwindled, then disappeared, leaving behind only their smaller bird relatives to carry their name into the future, to preserve some fragment of what they had been. The ash had done its work efficiently and thoroughly. It had stripped the world bare, reset the stage completely, silenced the giants and left space for something new to emerge. It is strange to think that without those years of gray skies, without the patience of that long winter, mammals might never have risen to dominance. Our story, the story of humans and all we've become, was written in the fallout of that ash, in the darkness and cold that followed the fire. Every step you take on soil today, anywhere on Earth, carries particles of that ancient catastrophe. Every layer of rock beneath your feet holds whispers of that time, chemical signatures and physical evidence of what happened. And still, if you close your eyes and really try to imagine it, you can almost picture it clearly. The dim world wrapped in perpetual twilight, the endless dusk that lasted for years, the soft fall of ash that muffled every sound and covered every surface. The earth wrapped in a blanket not of comfort but of suffocation, of silence. A silence so heavy, so profound, that even millions of years later it leaves its trace in the stones we study, in the bones we find, in the memories of a planet that once drowned in its own sky, that once wore its catastrophe like a shroud it couldn't remove. The fires had faded to embers, their fury finally exhausted. The ground had stopped convulsing with its worst shocks, though tremors still came occasionally. And the waves that had swallowed coastlines eventually lost their fury, their energy dissipating across vast distances. But the world was far from recovery, far from anything that could be called normal. The ash that drifted down from the sky was only part of the story, only one layer of the catastrophe. The real transformation, the deepest change, began when the atmosphere itself thickened into a veil so dense that the sun disappeared almost completely. It was not just dim twilight anymore, not just reduced light. It was night, true darkness. Not the ordinary night that ends with dawn, that comes and goes in a predictable rhythm, but a night that lingered heavy and suffocating for months that stretched into years, for a duration that exceeded the lifespan of many species. This was the longest night Earth had ever known in hundreds of millions of years. Imagine waking each day, if you can call it day, to the same darkness, to the same oppressive gloom. The sun, if it showed itself at all, was no more than a pale disk barely visible through the haze, blurred and feeble, a ghost of what it should be. Its rays scattered by soot and sulfur drifting high in the stratosphere, unable to penetrate to the surface with any meaningful energy. Daylight looked like dusk at best, and dusk looked like the edge of total blackness. For plants, organisms that had evolved over hundreds of millions of years to convert sunlight into energy, it was a death sentence. Without light, photosynthesis stopped completely. Trees that had survived the fires somehow starved slowly, their leaves wilting and falling until branches were bare. Grasses failed to sprout from seeds or from roots. Flowers remained closed, their petals never opening because the signal to bloom never came. Forests stood silent and skeletal, monuments to what had been. The green fabric of the earth, the foundation of all terrestrial ecosystems, unraveled in weeks, leaving only brown and gray and black. For the creatures that depended on plants that had evolved to eat vegetation, the change was swift and merciless beyond description. Herbivorous dinosaurs wandered through landscapes stripped of food, their evolutionary programming still driving them to seek vegetation that no longer existed. Their great bodies, built for constant grazing, for processing massive amounts of plant matter, found nothing to sustain them. The smaller among them, the more agile ones, tried to dig for roots, tried to strip bark from trees, tried to chew whatever scraps remained. But it was not enough, not nearly enough to sustain bodies that size. They weakened quickly, their ribs showing through their skin, their movements slowing as starvation set in. Predators that had relied on their abundance followed close behind in the death spiral, first feeding on the sick and dying, finding easy prey, then finding fewer and fewer meals as their food source vanished, until hunger claimed them too, until they too became victims of the darkness. The giant world of dinosaurs, once so unstoppable, so dominant, collapsed under the weight of hunger in a way that must have been agonizing to witness. Insects fared no better at first. Those that had fed on flowers, that depended on nectar and pollen, found no blooms to visit anywhere. Those that had lived on leaves, eating fresh vegetation, starved alongside their hosts. But scavengers, those insects and other creatures that thrived on decay, found themselves in temporary abundance as bodies accumulated. As forests withered and died, as life itself faltered across the planet, carrion feeders grew fat on death. Beetles, flies, and tiny worms multiplied in the soil, feeding on the collapse, becoming one of the few engines still running in the ecosystem, breaking down the dead into nutrients that would one day matter again, that would one day feed new life. Though in that moment it seemed pointless, as if the earth were simply composting itself in vain, processing death with no hope of rebirth. The oceans too darkened under the ash and soot, with light blocked from reaching the surface, with even the uppermost layers in shadow. Phytoplankton died in massive numbers, entire populations disappearing. These microscopic plants were the foundation of all marine life, the primary producers that supported everything else. And as they vanished by the billions, so did the zooplankton that fed on them, and so on up the chain in a cascade that emptied the seas. Fish that had filled the seas swam in barren waters, finding less and less food. Ammonites, those coiled-shelled creatures that had thrived for hundreds of millions of years, that had survived previous extinctions, vanished entirely from the fossil record. The great marine reptiles, mosasaurs and plesiosaurs that had ruled the oceans, starved soon after, their large bodies demanding food that no longer existed. Even coral reefs, those ancient architects of the sea that had built structures for millions of years, bleached and crumbled in the dark, cold water, their symbiotic algae dying, leaving only white skeletons. The temperature of the planet fell steadily and significantly. Without sunlight to warm it, without that constant input of energy, heat drained away inexorably. Average global temperatures dropped by more than 10 degrees Celsius, and in some places by much more. Regions that had been lush and warm just months before froze solid. Snow fell in areas that had not seen it in millions of years, if ever. Lakes froze over, their surfaces turning to ice. Rivers slowed as ice formed at their edges. Frost spread across ash-covered plains, creating surreal landscapes. Animals that had depended on warmth to regulate their bodies, cold-blooded creatures, stiffened in the chill and died. Amphibians, already sensitive to changes in their environment, disappeared in many places entirely. Only those with ways to keep themselves warm, mammals with fur, birds with feathers, had a better chance of survival, though even they struggled against the unrelenting scarcity of food and the cold that penetrated everything. To survive in this longest night, in this period of darkness and cold, creatures turned inward, became shadows of what they had been. Mammals curled together in burrows, conserving heat and energy through huddling, through shared warmth. They gnawed on roots, on seeds, on insects, living lean and small, surviving day to day. Some may have entered states like hibernation, slowing their metabolisms dramatically to endure stretches of famine, though we can only speculate. Birds clung to seeds, the one form of plant life that endured in the dark, their strong beaks evolution's answer to hard shells, cracking them open to reach the last stores of nutrients. Crocodiles slipped into deeper waters, slowing their bodies almost to stillness, surviving on the reserves in their muscles and the occasional meal that floated their way, their ancient survival strategies serving them once again. Life shrank, hid, and waited with no guarantee that waiting would pay off. But waiting was not easy, was perhaps the hardest thing of all. The night stretched on for what must have seemed like forever to any creature experiencing it. Scientists today estimate that the skies remained dark for at least a year and a half, maybe longer, maybe 2 or 3 years before significant light returned. That might sound short when measured in years, but to a creature living day to day, it was an eternity beyond comprehension. Generations of small animals lived and died without ever seeing a true sunrise, without ever knowing what full daylight looked like. Whole lineages vanished in that span, unable to adapt quickly enough. Plants that could not store energy in roots or seeds perished entirely, their genetic lines ending. Forests thinned into graveyards of standing trunks, silent monuments to what had been. Ecosystems collapsed so thoroughly that when light finally returned, when the darkness finally began to lift, the survivors were strangers in their own lands, inheriting a world completely transformed. The psychological effect, if we dare to imagine it, if we try to put ourselves in the place of these creatures, must have been overwhelming. Animals are not philosophers, do not contemplate their fate, but they are aware of cycles, of patterns. They know the rhythm of day and night, of seasons, of warmth and cold. These rhythms guide their behavior, trigger their instincts. To live in a world where dawn never truly came, where the cycles that had governed life for millions of years simply stopped, must have been bewildering and deeply disturbing. The cues that guided migration vanished. The signals that triggered breeding disappeared. The patterns that guided feeding became meaningless. Birds that once navigated by the sun had no guide, flew in circles or stayed grounded. Plants that once flowered by seasonal light cues never bloomed, their reproductive cycles interrupted indefinitely. The entire calendar of life, the clockwork that had governed ecosystems for millions of years, was erased, leaving creatures to navigate by instinct alone in a world where instinct no longer applied. We can see echoes of this disruption preserved in fossils, frozen evidence of the struggle. Growth rings in fossilized bones of survivors show stress, visible bands that record famine and slow development, that tell us these animals were barely hanging on. Shells of surviving clams show chemical signatures of colder waters, isotopic ratios that reveal the temperature drop. Layers of sediment from lakes record sudden die-offs of algae and fish, mass mortality events preserved in stone. Every record we uncover, every sample we analyze, tells the same story from every corner of the globe. A world where time itself seemed to pause, locked in a night that refused to end, caught in a moment that stretched beyond endurance. It's easy to think of extinction as a single event, a sudden catastrophe that wipes life away in a moment, like flipping a switch. But the truth is slower and crueler, more like watching something precious drain away drop by drop. The impact itself was the spark, the initial violence that started everything. The firestorm was the first blow, immediate and devastating. The shock waves were the second, shaking the foundations. The ash was the third, blocking the sun. And then came the longest night, the lingering cold famine that sealed the fate of species that had survived the first onslaught, that had made it through the initial catastrophe, only to face an even greater test. Dinosaurs did not vanish in a day, did not disappear in a single dramatic moment. They dwindled across years, each generation smaller and weaker than the last. Each sunrise, what little there was of it, dimmer than before. Each season colder and more hostile. Each generation producing fewer offspring until finally, in places scattered across the globe, they were simply gone. The silence where their calls had been was absolute. And yet, even in this grim span, even in these darkest years, life did not give up entirely. Life never gives up. Seeds endured in the soil, waiting with the infinite patience that only seeds possess. Burrowing mammals carried on, scratching out existence in tunnels and dens. Birds clung to the hard bounty of seeds, their beaks perfectly adapted for this challenge. Insects adapted to feed on decay, on death, on whatever organic matter remained. In the deep oceans, near volcanic vents where light had never been needed, where chemosynthesis replaced photosynthesis, communities thrived as if nothing had changed on the surface, as if the catastrophe was happening in another world. These small bastions of survival, these scattered refuges, were the threads that kept the tapestry of life from unraveling completely, that maintained continuity across the catastrophe. The longest night was not the end of Earth's story, not the final chapter. It was the beginning of a new one, a transformation from one age to another, though no creature living in that darkness could have known it, could have imagined what would come after. For humans today, safe in our comfortable present, it is difficult to truly imagine such darkness, to comprehend what years without proper sunlight would mean. The closest we come is during volcanic eruptions when ash clouds dim the skies for weeks or months, creating what we call volcanic winters. In 1815, the eruption of Mount Tambora in Indonesia caused what became known as the year without a summer, plunging much of the world into crop failure and famine, killing hundreds of thousands. That event lasted a single year with temperatures dropping only a few degrees, and it was devastating to human civilization. Multiply that effect many times over, extend it for years instead of months, and you glimpse the scale of the impact winter. You begin to understand what Earth experienced. The longest night left its mark not only in rocks and bones, but in the trajectory of life itself. It cleared the stage ruthlessly and completely for mammals to expand when light finally returned. It forced survivors to adapt to scarcity, to cold, to unpredictability in ways that shaped their evolution. And when the sun finally did return, when the veil began to lift, it revealed a world that no longer belonged to giants, but to the small, the adaptable, the resilient. A world waiting to be claimed by whoever could survive. So the night did end, though not quickly, not gently, not in a single dramatic sunrise. Light crept back slowly over months and years, timid at first as if afraid to return, then stronger as the particles settled and the atmosphere cleared. Plants sprouted again from seeds that had waited in the soil, green shoots pushing through gray ash like hope, breaking through despair. Insects followed, then the animals that fed on them, slowly rebuilding the food chains. Forests began to stitch themselves back together, one tree at a time. The earth turned from black to green again, transformed but alive. But the memory of that night remained, written in stone, preserved in fossils. It is written in every mammal that learned to hide and wait, every bird that learned to crack seeds, every ecosystem that rebuilt from almost nothing. And perhaps in some strange way, though they cannot know it, the memory lingers even in us, in humans who are the distant descendants of those survivors. For we are children of that night, descendants of creatures that endured it, shaped by its silence and its scarcity in ways we cannot fully comprehend. Without it, without those years of darkness, there would be no mammals in the forms we know, no primates swinging through trees, no humans to look back and tell the story, to marvel at what came before. The longest night was not just a tragedy, not just a period of suffering and death. It was a turning point in Earth's history, a reset, a doorway from one age to another. And as Earth spun on through space, carrying its scars and its survivors, as the ash continued to fall and the air continued to clear, the sun prepared to return in full strength. But before that light could bring renewal, before the world could truly begin to heal, there were still more trials ahead for the survivors, more challenges for the oceans, for the climate, and for the fragile life that had made it this far into the dark. The darkness did not lift quickly or all at once, did not recede in a smooth progression. Even as the ash began its long fall through the air, settling slowly onto land and sea, and the sulfur haze thinned in patches, the heat that once wrapped the planet had already bled away into the cold of space. The fires had used up enormous amounts of oxygen in their burning. The soot had blocked most of the sunlight, preventing the planet from warming, and the atmosphere now wore a film of particles that scattered and reflected what little light filtered in, sending it back to space. The result was not only dim days, but a steady, relentless drop in temperature that pressed into every corner of the world, that affected every living thing. The ground released its stored warmth night after night with nothing to replace it. Lakes lost heat to cold skies, their surfaces cooling, and winds carried chill across burned plains and empty coasts, spreading the cold everywhere. What had begun as a sky problem, as a blocking of sunlight, became a ground problem as the earth itself grew cold, and then a water problem as oceans and lakes chilled, and then a problem for blood and bone, for every creature trying to maintain body temperature. It was not just dark anymore. It was cold, deeply, penetratingly cold. This cold did not arrive like a winter storm with a clear start and a predictable end, with the promise of spring. It crept into the world gradually. A week that felt merely brisk turned into a month of frost, and then a season where ice lingered after midday. Places that had known only mild nights found thin films of ice at dawn that didn't melt. Ponds sealed over with ice that thickened. Shallow marshes stiffened into solid surfaces. Rivers grew sluggish at the edges, then locked in place in quiet reaches. Their flow stopped. The cooling touched everything that exchanged heat with air or water, affected every organism in ways both obvious and subtle. Cold-blooded animals fell silent first, their bodies no longer able to keep pace with the demands of life. Reptiles that had basked on warm banks in the Cretaceous sun, that had relied on external heat sources, became statues in the dimness, unable to move, unable to hunt, unable to flee. Amphibians that had hidden under damp leaves found those leaves brittle and frozen, offering no protection. Even insects slowed, their movements turning jerky and sparse, their life cycles interrupted, their populations crashing in the cold. Plants carried the cold differently from animals. After the light failed, photosynthesis had stopped, but many species still retained the machinery of life in their roots and stems, holding out for a break in the dimness, waiting for conditions to improve. The temperature drop forced a second failure on top of the first. Cells that had been stressed by hunger, by lack of light, now contended with ice crystals forming in their tissues. Some species had evolved proteins and sugars that helped bind water and reduce freezing damage, antifreeze compounds that protected cells. But many did not have these adaptations. Needles browned on conifers. Broad leaves blackened and fell. And in the burned landscapes where ash sat in a thin, insulating layer over the ground, the soil below chilled fast and deep, freezing solid. Seeds, however, told a different story, offered a glimmer of hope. Encased in protective coats, dry and dormant, often buried safely beneath the surface, they endured the cold with remarkable resilience. The cold made them wait longer, extended their dormancy, but waiting was not the enemy for a seed. Waiting was a strategy, perhaps their greatest strategy. In the oceans, cooling was immediate and severe at the surface. Sunlight had already been blocked by soot and dust, so the topmost layers lost heat to the air without any replenishment from above, without the sun's warming rays. Winds stirred these cold layers, mixing cold water downward into the depths. The upper ocean became dense and heavy, sinking in places and driving up deeper water that was colder still, that had never seen sunlight. This overturning rearranged the chemistry of entire ocean basins in ways that would persist for thousands of years. Nutrients that had been locked below came up in these upwellings, but the phytoplankton that would normally seize that bounty, that would normally bloom in response to nutrients, lacked the light to use it. The nutrients went to waste. Dead organisms from the first wave of extinction, from the immediate aftermath of the impact, settled into deeper water and decomposed there, their bodies broken down by bacteria. This decomposition used up oxygen in the process, consuming what little remained. Zones of low oxygen, called anoxic zones, spread through ocean basins like stains. Fish, already starving with the collapse of plankton populations, found their gills pulling water that held less and less of what they needed to survive. At coastlines scoured by tsunamis, in regions where the waves had stripped away everything, the nearshore waters filled with sediments and plant debris, turning dark as tea, sharp with acids leached from the ash. Cooling made these nearshore waters slow to mix, turning some inlets into cold, still traps where nothing could survive for long. On land, the chill rewrote behavior in fundamental ways. Mammals that had used the cover of darkness to forage for insects and fallen fruit, that had developed nocturnal habits to avoid dinosaur predators, were now living in a permanent night with the added challenge of frost and cold. They compressed their lives into shorter, more cautious ventures from shelter, minimizing exposure. They used stored fat when they had it, and the warmth of clustered bodies, pressing together in burrows to conserve heat, to bridge the longer gaps between meals that grew more sparse. Small size helped tremendously in this new world. What had kept mammals hidden under the rule of dinosaurs, what had made them insignificant and overlooked, now let them fit into cracks, tunnels, and burrows that held pockets of bearable heat, that trapped warmth. Fur mattered more than ever. Dense undercoats trapped thin layers of warm air against skin, created insulation. Oils in fur kept dampness out, prevented water from stealing heat. Teeth mattered too in this new reality. Seeds and roots were tough food in the best of times, requiring strong jaws and sharp teeth. But in the cold, they became lifelines, the only reliable food source, and jaws built to gnaw could turn a buried cache into a winter's worth of calories, into survival. Birds found advantage in mobility, in their ability to fly and cover distances, but mobility demanded energy, and energy was scarce, desperately scarce. Those that ate seeds had an edge over others. Their beaks could split husks, could access food that others couldn't, and their guts could pull useful sugars from dry stores that had survived in soil and in the hollows of fire-blackened trunks. Those birds that depended on insects, that needed protein, chased dwindling swarms by day, and searched bark and leaf litter by night for larvae and dormant adults. Feathers, with their unmatched insulation properties, kept core temperatures in range even when air temperatures dropped near freezing. But the bill came due in the form of higher food needs. Birds need to eat constantly to maintain their metabolism. Many lineages would not have met that bill, would have starved. The ones that did kept moving, kept scouring wider areas, sometimes taking to coastlines where cold winds were hardest, but tide lines still yielded scraps of food washed up by the waves. The cold touched the chemistry of the atmosphere in ways that were not visible, but were consequential for the future. Sulfur aerosols continued to reflect sunlight even as the soot began to settle, and they encouraged the formation of more cloud droplets, brightening clouds and keeping more of the sun's energy from reaching the ground. With fires largely out, soot production fell, but the particles already aloft persisted, especially those small enough to ride the stratospheric winds for years, circling the globe again and again. Ozone damage in the upper atmosphere left gaps that would matter later when light returned, exposing surviving plants and animals to hard ultraviolet radiation. But during the deepest part of the cooling, during the heart of the impact winter, the main issue was simple and brutal. The daily flow of energy into the system, the sunlight that normally powered everything, had been throttled down to almost nothing. Ground that cooled quickly emitted less water vapor into the air. And with less vapor came fewer and weaker storms in some regions, a breakdown of normal weather patterns. In others, moisture flowing over newly cold surfaces condensed and fell as snow, sometimes in places that had not seen snow in tens of millions of years, if ever. Snow cover, bright and reflective, returned even more sunlight to space when any managed to get through, reinforcing the chill in a feedback loop. After fires, many hillsides had lost their plant cover entirely, left bare and exposed. And when the ground froze and then thawed in cycles, it heaved and slumped. With each freeze, water in the soil expanded, pushing stones and roots upward. With each partial thaw, the loosened surface slid downslope. Small mammals found their burrow ceilings dropping onto their backs and had to dig them out again. Reptiles that had used shallow burrows, that had dug only deep enough to escape the heat, were forced to go lower, seeking layers that did not wrench and buckle with each temperature cycle. Predators that remained, including some small theropod dinosaurs that would not make it much farther into the future, tested new behaviors in their desperation. A scavenger in cold times spends more energy searching than they gain from eating unless they're very lucky. The math becomes unforgiving, the energy equation impossible to balance. Those predators that succeeded, that managed to survive, learned to find the leeward sides of ridges where snow accumulated less, where conditions were slightly more favorable. To watch the edges of frozen lakes, where fish sometimes came too close to the underside of the ice and could be extracted. To patrol the margins of fire-killed forests, where fallen trunks trapped drifted leaves, and the insects beneath them provided tiny morsels of protein. The cold created patterns in the landscape, and those patterns were maps for feeding, breathing, and sheltering, but only for the few that could read them, that could learn fast enough. There were refuges scattered across the cold world, rare but real, offering hope. Geothermal areas, places where heat from Earth's interior reached the surface, offered thawed ground, warm water, and a stable microclimate that persisted regardless of atmospheric conditions. Edges of volcanic fields in places where groundwater rose warm gave frogs and insects a toehold, a place to wait out the cold. Caves held steady temperatures compared to the wildly fluctuating surface, their depths insulated by rock. South-facing slopes in the mid-latitudes caught what little slanted light there was, and stayed a degree or two warmer than flats and north faces, enough to make the difference between life and death. Along coasts, tidal pools that retained even a hint of geothermal warmth, or that exchanged with the sea in complex ways, avoided the hardest freezes. These refuges could not support the living mass that the world had carried before the impact, could not host the millions of creatures that had once thrived. But they gathered the survivors into concentrated pockets where interactions continued, where food chains limped along, where lineages persisted against the odds. Every cold season on a normal planet forces a pause, a redistribution of life, and a rhythm of scarcity and renewal. But this stretch of cold did not have spring at the ready, did not have relief waiting around the corner. The responses were pure improvisation stretched thin, survival strategies invented on the fly. Growth slowed in the bones of animals, visible in the fossil record. Lines in teeth growth bands recorded days of poor nutrition, documented the struggle. Shells laid down by clams and snails showed abrupt changes in isotopes consistent with cooler water and altered chemistry, written in calcium carbonate. In lake mud and shallow sea sediments, black layers revealed times when oxygen had gone missing from bottom waters, when decomposition had consumed it all, while coarse layers held the wreckage of storm surges and ice shove, of physical violence added to chemical stress. The earth kept all the receipts, preserved every detail. As the years of dimness wore on, as the impact winter stretched beyond what seemed endurable, the initial cause of cooling began to change in subtle ways. Fires had injected carbon dioxide into the air on a massive scale, billions of tons of it, and volcanic outgassing in the years after the impact, triggered perhaps by the seismic disruption, added more greenhouse gases. In an ordinary climate, that carbon dioxide would push temperatures upward, would warm the planet. But as long as the high atmosphere still held reflective aerosols, as long as particles scattered sunlight back to space, the greenhouse signal was muted, overpowered by the cooling effect of the ash. When the particles finally began to clear in a decisive way, when enough had settled that sunlight could penetrate again, the system did not smoothly return to the prior state. It wobbled and fluctuated. Regions with new snow cover remained bright and cold longer than others, reflecting light even when it returned. Oceans that had turned over and reorganized circulation patterns did not snap back to earlier patterns. Currents took new paths, flowed in different directions. And those new paths set different coastlines under different regimes of upwelling and downwelling, changing which areas were productive and which were barren. The first years after the deepest part of the cold, the initial recovery period, were not simply a smooth warm-up back to normal. They were a shuffle, an unstable transition. For land animals that had made it through the worst, that had survived the darkest and coldest period, the gradual easing of the cold created opportunities, but also new risks. Warmer spells encouraged movement and breeding, gave hope. But a late freeze could still kill exposed eggs, could still strip the thin food stores that had barely recovered. Many mammal lineages likely had shorter generations in this period, with small bodies that reached reproductive age quickly, with strategies that emphasized having more young rather than investing heavily in a few. Flexibility beat specialization every time. A generalist diet that included seeds, roots, carrion, and insects could ride out a patchy landscape of cold pockets and warmer corridors better than a narrow menu tied to a vanished plant or a now rare prey species. Plants began to reappear first as low, fast-growing forms that could exploit even brief windows of acceptable conditions. Grasses, already a presence by the late Cretaceous though not yet dominant, were well-positioned to spread on soil scoured by fire and freeze. Their growth points sat low, protected from grazing and cold snaps. Ferns, often early colonizers after disturbance throughout Earth's history, painted swaths of ground with new green when moisture and temperature allowed, when conditions aligned. Shrubs followed where roots could get purchase in soil that had been reorganized by frost heave and erosion, by the physical churning of freeze-thaw cycles. Trees returned slowly, cautiously. First as pioneers that tolerated harsh light and wind once the sky brightened, then as communities that could knit together a canopy again, that could create the shade and structure of true forest. Until then, the openness of the landscape favored animals that preferred edges and mosaics rather than deep forest, that thrived in transition zones. The cold's legacy lived on in bodies and behaviors long after the worst months had passed, long after temperatures had moderated. Fur density in mammalian descendants, in the lineages that would eventually lead to all modern mammals, tells a story of ancestors for whom warmth was survival, not comfort, for whom insulation meant life. The ability to lower metabolic rate, whether through full hibernation or shallow torpor, offered extra lives during periods when the temperature dropped hard and food ran out completely. Caching food, gathering and storing it, became a profitable skill that would persist. Seeds carried to barrows in better moments kept meat on bones in the lean ones, provided insurance against uncertainty. Barrow architecture itself likely improved through this period, with chambers placed at depths that stayed out of the frost's reach, and entrances angled to break wind and trap warm air. Social clustering would have been an advantage where it occurred, where shared heat saved calories that individuals couldn't spare. Even in birds, many modern behaviors like huddling, communal roosts, and synchronized foraging have echoes that make sense when traced back to ancestors that met long, cold nights with only a little food in their crops, with survival hanging by a thread. Rivers taught hard lessons too during the cold period. In the chill, ice formed along banks and reached out from shore, creating under-ice channels where water still moved in darkness. Fish took shelter there if oxygen levels allowed, if the water didn't freeze solid. Mammals learned that these margins were dangerous but rewarding places to hunt. Dangerous because thin ice could break and plunge them into freezing water. Rewarding because weakened fish could be reached through cracks and gaps, providing rare protein. When thaw pulses came, when temperatures briefly rose, ice rafts pushed sediment into new bars and flooded back channels that had been dry, creating temporary opportunities. Animals that tracked these small openings, that paid attention to the subtle signs, found food earlier than those that waited for a full seasonal shift, that relied on old patterns. In the seas, the first recovery was patchy and uneven. Where light returned enough to reach the surface, where conditions aligned, blooms of plankton came in bursts, sometimes large enough to deplete the remaining nutrients in a frenzy of growth and crash again in a boom-bust cycle. Cold water species spread into regions where warmth had retreated, expanding their ranges. Warm water species that somehow persisted were bottled into shrinking belts near the equator, compressed into smaller and smaller areas. The rearranged food webs favored opportunists that could feed on a mix of resources, including the steady rain of organic particles from dead and dying organisms above, the marine snow that drifted down constantly. Scavenging became a central function in both ocean and land ecosystems, knitting the system together when primary production was intermittent, when the normal flow of energy was disrupted. Cold by itself is a blunt tool, a simple stressor. What made this episode decisive? What made it an extinction event rather than just a difficult period? was the timing and the stacking of stresses one upon another. Light loss starved the base of the food web first. Fire destroyed cover and seed banks next. Waves stripped coasts of their ecosystems. Quakes broke the ground and disrupted habitats. Then the cold took what remained of momentum out of every living process that depended on steady input of energy. The sequence mattered tremendously. If cold had come first with bright skies, with full sunlight, many plants and animals could have braced for it, could have adapted. If darkness had come without cold, if temperatures had remained warm, some organisms might have scraped by on stored heat and delayed growth, waiting it out. Together, darkness and cold squeezed options until only the most adaptable, the best sheltered, and the luckiest moved forward into the future. It is tempting to cast this as an ordeal endured only by small things while large ones failed, to make it a simple story of size. But size alone did not seal fate, was not the only factor. A small creature with a narrow diet and a need for steady warmth was in as much trouble as a large grazer without grass. A large-bodied crocodile with a slow metabolism, with access to water that did not freeze solid, and with the ability to go weeks without a meal, was better positioned than a small specialist that needed nectar from flowers that no longer opened, that had evolved for a world that no longer existed. Cold blurred simple categories. The traits that carried weight, that determined survival, were the ones that lowered the daily cost of being alive, and that multiplied the ways to find calories when the landscape offered only meager choices. As the cold years stretched on, as they became the new normal, the memory of the warm, green Cretaceous faded from the surface world. The physical traces remained everywhere. Stumps charred by the first fires, trunks toppled and preserved in sediments, dunes of ash locked under thin layers of snow. But the daily experience of those who lived was now set by the new climate, by the cold reality. Air stung when breathed too deeply, burned lungs. Water taken by mouth leached heat from tongues and throats. Sound traveled differently over frozen ground, sharper and farther on quiet nights, muffled when snow fell again. Predators used those acoustics to hunt. Prey learned to listen through the hush, to detect danger by sound alone. The eventual easing, when it finally came, did not erase the cold's imprint. When light improved gradually and plants stirred in response, the first growth had to navigate soils altered by repeated freeze-thaw cycles, by acid rains from earlier months, and by the rearrangements pushed by storms under a different atmospheric circulation. That meant patchwork recovery, with some slopes greening while adjacent hollows stayed barren for years longer. Animals tracked the green as it spread, moving up slopes like a tide line following it. Those with enough range to relocate followed it successfully. Those bound to small areas, those with limited mobility, rose or fell with the luck of their patch, with whether green returned to their particular location. There is a hard clarity to cold that shapes evolutionary choices even for species that did not exist yet, that would evolve later. Later lineages would carry forward fat storage strategies refined in this period, seasonal coats that could thicken and thin, habits of seeking shelter, and flexible feeding strategies grounded in this long trial by ice. The cold did not simply kill. It sorted through the diversity of life, selecting. It winnowed a global inventory of forms down to the ones that knew how to run lean, hide well, and wait with patience. In places where ice grew thick on lakes, where winter seemed to last forever, spring thaws, when they finally came, broke up the ice with cracking sounds that echoed across kilometers. Shorelines collapsed under the shove of ice. Channels cut by moving ice created new paths for water and eventually for migrating animals. Fish populations snapped back in erratic pulses, unpredictably. Some years fry from a lucky hatch found nutrients and light aligned, and a cohort survived in large numbers. Other years, a late cold snap iced over spawning beds and ended a run before it began, killing an entire generation. That variability favored species that spread risk by spawning more widely and more often, that didn't put all their eggs in one basket. And it disfavored species tied to a narrow window of conditions, species that had evolved for predictability. The air itself learned new rhythms during the cold period. With less vegetation to slow winds to create friction, gusts scraped across open ground more freely, lifting dust and ash again and sending low, dirty clouds down valleys. Those winds cut heat from skin and fur, increasing the cost of any activity above ground, making exposure dangerous. The same winds piled snow into drifts that paradoxically protected the ground below from deeper freezing, creating insulated spaces. Under those insulating mounds of snow, seeds waited a little warmer, and small mammals tunneled through a stable world only a few centimeters high, a subnivean zone. Above the snow, it looked like a frozen desert, hostile and dead. Below, hidden from view, it functioned as a cramped but structured neighborhood where life continued. The cold also touched reproduction directly in ways that shaped which species survived. Eggs that needed stable warmth to develop failed more often in the temperature fluctuations. Species that carried young internally, that could regulate the temperature of developing offspring, had an advantage over those that laid eggs, as did those that could adjust the timing of breeding to match brief warm intervals, that could be flexible. Many lineages likely shifted during this period to smaller clutches and litters produced more often, trading quantity for the ability to try again sooner if conditions broke bad, if offspring didn't survive. Parental care, where it existed, made a larger difference than before. Warmth and protection from parents compensated for a harsher external world, gave offspring a better chance. Those changes were not conscious decisions as we think of them, not strategies planned out. They were evolutionary filters selecting for traits that paid off more under these new rules, under the harsh conditions. Even as the cold loosened its grip, even as temperatures began to moderate, the world it left behind looked unfamiliar compared to what had existed before the rock fell. Forest canopies were lower and patchier, where they existed at all. Open habitats were more common than closed forests. Food chains were shorter with fewer large animals, and more steps built around small, quick lives, around rapid reproduction. The cooling had pruned away many of the long-lived, slow-growing forms and emphasized speed, flexibility, and the efficient conversion of scarce resources into the next generation. That shift set the stage for everything that followed when warmth and light made generosity possible again. The planet was not moving toward a permanent deep freeze, was not locked into cold forever. The radiative balance would eventually tilt back, as aerosols fell out of the atmosphere and greenhouse gases accumulated. But those years when the cold ruled, when ice and frost dominated, left marks too deep to ignore or forget. They changed which seeds were in the soil bank, ready to sprout. They determined which animals knew how to endure scarcity. And they decided which coastlines, rivers, and ocean currents were ready to host the next round of growth when conditions improved. When the first true warm seasons finally returned after years of cold, they met a biosphere made cautious and clever by deprivation, shaped by hardship into something new. And so the slow turn continued, inexorable as the planet's rotation. Ice thinned on lakes that had been locked under its weight for seasons. Winds lost some of their bite as plants began to roughen the ground again, creating friction, slowing the air. The atmosphere itself regained a little softness, a little moisture. The same survivors that had tunneled, clustered, and rationed through the worst now began to explore farther from shelter, testing the world. Cold still visited often, still came in waves, but it no longer defined every hour of every day. In the spaces the cold had carved out, in the opportunities it had created through destruction. New patterns began to write themselves in the behaviors and bodies of survivors, pointing toward a different world than the one the dinosaurs had known. The chill had done its work thoroughly. What came next would depend on how the light returned, on how quickly the sun could break through, and on how the first green spread back over the black and gray landscape that remained. For more than 150 million years, a span of time almost impossible for human minds to truly grasp, the dinosaurs had been the ruling presence on land, the dominant force shaping terrestrial ecosystems. They were not just another group of animals competing for space. They were the backbone of entire ecosystems, the largest bodies moving across the Earth, shaping landscapes by their sheer numbers and enormous appetites. Their footsteps were thunder that could be heard for miles. Their shadows were long, stretching across plains and through forests. Their presence was inescapable, defining what it meant to be alive on land. From the long-necked titans that reached into the highest treetops, browsing on leaves no other creature could reach, to the horned herds that thundered across plains in migrations that must have been spectacular to witness. From predators with jaws that could crush bone with ease to feathered hunters no larger than a modern hawk. They filled every role available to them, occupied every niche. They were the giants, and they lived as if nothing could challenge their dominance, as if their reign would last forever. But the rock that fell from the sky rewrote those rules in an instant. And in the dark, frozen years that followed, in the world stripped of food and warmth, their strength became their downfall. Their size became a liability. It is important to understand that extinction is rarely instant, rarely as simple as it appears in summary. When we say the dinosaurs died out, when we speak of their extinction, it is tempting to picture them collapsing in unison, the entire world of giants falling silent at once, in a single dramatic moment. The truth was slower, more drawn out, crueler in its gradual progression. When the fires swept the forests and the ash blotted out the sun, when darkness fell across the world, the end did not arrive in a single blow. It arrived as hunger, as thirst, as a creeping weakness that hollowed them from within, day by day. They were enormous, yes, magnificent in their size. But that enormity demanded constant food, unrelenting consumption. A sauropod needed hundreds of pounds of vegetation each day just to sustain its bulk, to keep its massive body functioning. A tyrannosaur needed steady prey to fuel the engines of its powerful muscles, to maintain its position as apex predator. When the plants failed, when photosynthesis stopped and vegetation withered, when the herbivores dwindled in number, when carcasses grew scarce, the giants had no way to shrink their appetites to match the world that was shrinking around them. They couldn't adapt fast enough, couldn't change their fundamental biology in a few generations. Picture a hadrosaur herd if you can. Really try to imagine it. Once a river of bodies flowing across a fertile plain, hundreds or thousands of individuals moving together, their calls echoing in waves across the landscape, their young tucked within the mass for protection from predators. Now imagine that same herd in the aftermath of the impact, wandering a transformed world. The plain is covered in ash, gray and lifeless. The river they once followed is clogged with debris, its water murky. The trees that once provided shelter are blackened stumps reaching toward a dark sky. They move slowly now, their ribs showing through their skin, their eyes dull with hunger. Their calls no longer waves of vibrant communication, no longer sounds of strength, but ragged cries of confusion and desperation. The young stumble on weakened legs, struggling to keep up. Predators circle, thinner themselves, desperate, striking not for dominance or territory but for survival, for the calories they need to live one more day. Every step forward is heavier than the last, every bite of bark or root insufficient to sustain bodies built for abundance. And day by day, week by week, the herd dwindles, shrinks. Individuals fall behind and don't catch up. Bodies collapse and don't rise. The herd that once numbered in the hundreds is reduced to dozens, then to a handful, then to none. Predators fared no better in this transformed world. A tyrannosaur's body was a masterpiece of evolutionary engineering, a perfect killing machine honed over millions of years. Its skull was built for delivering tremendous force, its muscles for explosive speed and crushing strength. But power is expensive, demands constant fuel. Without prey to match its scale, without the abundant herbivores that had sustained it, that masterpiece became a liability, a body that demanded more energy than could be found. A starving tyrannosaur, once the undisputed terror of the plains, was reduced to scavenging in the gray forests, competing with smaller, more efficient hunters, fighting smaller predators over scraps of carrion, over bodies that offered barely enough calories to justify the energy spent finding them, risking injury with every confrontation because there would be no healing, no recovery if the next meal did not come soon enough. Some likely turned on their own kind in desperation, a breakdown of all normal social structures. Battles not for territory or mating rights but for calories, for the energy needed to survive another day. The slow collapse of prey populations meant that each encounter, each chase, each strike drained more energy than it returned. The mathematics of predation, usually so favorable, turned against them. For animals whose bodies were optimized for power rather than efficiency, for explosive hunting rather than patient scavenging, the new world was impossible to navigate. The cold sharpened the decline, added another layer of stress. Dinosaurs were not entirely cold-blooded in the way modern reptiles are today. Many scientists believe they were warm-blooded, or at least had high metabolic rates, with some species covered in feathers for insulation, with active lifestyles that required internal temperature regulation. But warm blood brings with it a terrible cost in times of scarcity. It demands constant intake of food to fuel the metabolic fire, to maintain body temperature. Small birds today can stretch their survival by eating seeds, by slowing their metabolism slightly, by huddling with others for warmth. Giant dinosaurs could not make these adjustments quickly enough. Their metabolisms demanded more than the barren world could offer, far more. Even those dinosaurs that tried to endure by migrating, by moving to new areas in search of food, found no refuge anywhere. The darkness and chill were global, affected every continent. There was no untouched paradise waiting beyond the horizon, no promised land where the sun still shone and plants still grew. The catastrophe had touched every corner of the world without exception. In the oceans, the parallel story unfolded with equal devastation. Giant marine reptiles faced the same spiral of scarcity and starvation. Mosasaurs, the apex predators of the seas, massive creatures that had thrived on abundant fish and ammonites, watched their food supply collapse. When the plankton at the bottom of the food chain died in massive numbers, when the foundation crumbled, the ladder of life collapsed upward level by level. Fish starved as their food disappeared. Ammonites, after hundreds of millions of years of success, disappeared entirely from the fossil record. And soon the mosasaurs followed them into extinction, their size once a mark of evolutionary supremacy, now an anchor dragging them down into oblivion. For pterosaurs, the great flying reptiles of the skies, creatures that had dominated the air for millions of years, the story was much the same, equally tragic. They had soared above Cretaceous coasts in vast numbers, some species with wingspans wider than small airplanes, creatures so large they seem impossible to our modern eyes. They fed on fish snatched from the sea, on small animals caught on land, on carrion when they could find it. But fish populations crashed in the cold, dark oceans. Land animals dwindled to almost nothing, and carrion was soon picked clean by the few scavengers that remained. Their fragile bones, perfectly engineered for flight through evolutionary refinement, but poor for withstanding hardship and stress, marked them as temporary survivors at best. The skies grew emptier day by day as their forms vanished from the air, leaving behind only the smaller, feathered descendants of the rapads, the lineage that we call birds today. The collapse of the giants was not only ecological, not only a matter of food chains and energy flow. It was audible if anyone had been there to listen, to mark the change. The earth grew quieter day by day, losing its voice. The trumpeting of hadrosaurs, calls that once carried for miles, fell silent. The roars of tyrannosaurs, sounds that must have struck fear into every creature that heard them, ceased. The wing beats of pterosaurs, the rush of air over vast membranes, disappeared from the sky. These sounds vanished one by one, replaced by silence, by an emptiness that was almost tangible. Forests that had once trembled with the passage of sauropods, where the ground shook with every step, now stood still and quiet. Ash falling softly where leaves used to rustle in the breeze. Rivers once churned by crossing herds, by hundreds of massive bodies pushing through the water, now slid silently past empty banks. The giants left behind emptiness, a void, and that emptiness became the stage on which something new could appear, could evolve. The fossil record shows us this transition in fragments, in pieces scattered across the world. In the very last layers of Cretaceous rock, in the strata just below that iridium-rich boundary, dinosaur bones still appear, though often they're small, thin, from individuals that likely died young, that never reached full size. Above that boundary layer, above that thin line of clay, they vanish almost completely. What remains instead in the rocks above are the traces of mammals, small and previously insignificant, of birds, adapting and diversifying, of reptiles like crocodiles and turtles that had found ways to endure. The giants vanish from the record, and the small inherit the earth. This pattern is not accidental, not random. It is the consequence of scale, of size becoming a death sentence. Large animals need stability above all else. They need vast food webs operating smoothly, reliable climates, predictable seasons. Small animals can bend with instability, can survive on scraps, can retreat into burrows and other refuges, can wait for better days with minimal resources. When catastrophe strikes, when stability shatters, size becomes fragility rather than strength. It is sobering, deeply humbling to realize how close the balance was, how narrow the margin between survival and extinction. If conditions had shifted differently, if some lineages of dinosaurs had managed to persist just a little longer, just a few more years or decades, perhaps they might have re-established themselves once the sun returned, once food became available again. Perhaps the age of mammals would never have dawned, and Earth would still be a world of dinosaurs today. But the weight of extinction was too heavy, the night too long, the cold too sharp, the food too scarce. The giants, magnificent as they were, supremely adapted as they had been, could not make it across that gulf, could not bridge the gap between the world that was and the world that would be. And yet they did not vanish entirely, not completely. Their legacy continues. Birds carry their genetic heritage into the present. Every sparrow outside your window, every hawk riding the thermal currents, every penguin sliding across Antarctic ice, every hummingbird hovering impossibly by a flower, they are dinosaurs, living dinosaurs. The descendants of the ones that endured by being small enough, by eating seeds, by hiding in the cracks and crevices of catastrophe. The giants died, their massive forms lost forever. But their lineage still sings in the trees, still builds nests in the spring, still soars on the wind. Their voices are softer now, their bodies smaller, more scattered across diverse forms, but they remain, a living connection to that ancient world. For the mammals that survived the catastrophe, that made it through the darkness and cold. The disappearance of the giants was opportunity on a scale never before possible. Suddenly, almost overnight in geological terms, the world was open, available. Forest floors no longer shook with heavy feet. Plains no longer belonged to herds the size of houses. Skies no longer darkened with the wings of immense flying reptiles. The stage was cleared completely, all the major roles suddenly vacant. What had once been an overshadowed existence, a life lived in the margins, became the main story. And slowly, cautiously, testing each step, the mammals began to expand into niches left vacant by extinction, began to experiment with forms and sizes they had never attempted before. It didn't happen overnight, wasn't a sudden transformation. Recovery was slow, tentative, punctuated by setbacks and failures. But the giants were gone, removed from the equation. And with them, the old order of life, the hierarchy that had persisted for more than 150 million years, was gone as well, swept away. The end of the giants is a powerful reminder of fragility, of how precarious even the most successful existence can be. Supremacy does not guarantee survival in the face of catastrophe. Scale does not protect against collapse when conditions change. For millions of years, the dinosaurs had been unchallenged, their world as stable as any ecosystem could be. But a single moment, a single cosmic accident, an impact that lasted mere seconds, shifted the balance irrevocably. And the very traits that had made them rulers of the earth, their size, their specialization, their optimization for specific conditions, became their undoing when those conditions vanished. In their absence, in the empty world they left behind, life reorganized itself into new patterns. Smaller forms, more cautious in their approach, more adaptable in their strategies, began to fill the vacant spaces. And from that new order, from that restructured web of life, a very different earth began to rise, began to take shape. The giants had ruled in daylight, in warmth, in abundance, in a world rich with food. Their end came in darkness, in cold and scarcity, in conditions their bodies simply could not handle. And yet, even in their absence, even with their voices silenced forever, the world did not remain empty for long. New giants would come in time, millions of years later, though of different shapes and forms. Mammals would eventually produce their own giants, creatures like mammoths and giant ground sloths. New rulers would rise, new apex predators would claim the top of food chains, though never again in quite the same forms as the dinosaurs. The age of the dinosaurs was closed, that chapter finished. But the story of Earth was far from over, was in fact just beginning a new volume. And so, the silence after their passing, the emptiness they left behind, was not only grief and loss, not only the end of something magnificent. It was also potential possibility, a blank canvas. From the ashes of their world, from the bones of their fallen bodies scattered across continents, from the spaces they vacated, evolution began to write a new chapter with new characters, one that would eventually include us, include humans. The giants were gone, their reign ended, but their shadows stretched forward through time, shaping everything that came after in ways both obvious and subtle, influencing the trajectory of life on Earth for all the millions of years that followed. On land, the giants had fallen silent, their calls no longer echoing across plains and through forests. The forests themselves lay blackened and bare, skeletal remains of what had been. But the oceans had their own catastrophe to endure, their own version of the apocalypse. If the surface world was cloaked in ash and cold, was transformed into a gray wasteland, the seas below responded in ways both immediate and insidious, both violent and gradual. To an animal living in the Cretaceous ocean, to a creature that had known only abundance, the change was almost as abrupt as the firestorm on land, though it played out differently. For millions of years, Those waters had been rich and productive beyond measure, alive with fish of every size, with ammonites spiraling through the depths, with giant marine reptiles ruling as apex predators, and with clouds of plankton that fed everything else, forming the foundation of oceanic life. The sea had been a kingdom in its own right, vast and generous, teeming with life in every cubic meter. But the impact shifted it overnight into something unrecognizable, something strange and hostile. When the asteroid struck with its terrible force, the first effect on the water was pure violence, immediate and catastrophic. A blast wave shot through the Gulf of Mexico, a pressure wave moving through water faster than any tsunami, vaporizing water instantly in the immediate vicinity, flinging cubic miles of ocean into the atmosphere as if it weighed nothing. The crater collapse created tsunamis hundreds of meters tall, walls of water that defied imagination, racing outward across the seas at speeds exceeding commercial aircraft. Those waves reached distant shores hours later, sweeping away everything in their path, dragging forests and soil into the surf, tearing ancient coral reefs from their foundations, reefs that had taken millions of years to build. The very first stage of the marine disaster was physical ruin, immediate destruction, the kind that could be measured in toppled reefs, in drowned river deltas, in beaches turned inside out, in coastlines completely redrawn. But even as the waves receded, even as the immediate violence subsided, the ocean was only beginning to change in more fundamental ways. The ash and soot that dimmed the skies on land also fell onto the seas in vast quantities, billions of tons of it. At first, it formed a thin layer on the surface, but rain carried more of it down constantly, mixing it into the surface waters, spreading it. It blocked light just as it had blocked sunlight on land, prevented it from penetrating into the water. For phytoplankton, the microscopic plants floating in the upper layers of the ocean, this was fatal, an immediate death sentence. They could not photosynthesize in darkness, could not produce the energy and oxygen they needed. Entire populations collapsed within weeks, disappeared from vast regions of ocean, and with them, the zooplankton that grazed on them began to starve, and the fish that fed on zooplankton followed, and everything that fed on fish began to struggle. The ladder of life in the oceans proved as fragile as it had been on land, perhaps more so. The loss of phytoplankton did more than starve the seas, had effects beyond just removing a food source. It altered the very chemistry of the water in profound ways. Normally, these tiny organisms absorb enormous amounts of carbon dioxide from the water and release oxygen in return, helping balance both ocean and atmosphere in a cycle that had operated for hundreds of millions of years. Without them, carbon dioxide built up in the water, accumulated. The oceans absorbed vast amounts of it from the atmosphere, from the carbon dioxide released by burning forests, and from the impact itself. But instead of being processed by life, being incorporated into living cells, it dissolved directly into the water itself, forming carbonic acid. Slowly, subtly but inexorably, the seas turned more acidic, their pH dropping. Creatures with shells made of calcium carbonate, the building blocks of shells and skeletons, creatures like ammonites and clams and corals and countless species of plankton, found their armor weakening, dissolving around them as if it were made of sugar. Whole lineages that had built their survival on shells, that had protected themselves with calcium carbonate for millions of years, discovered that their protection had become porous, inadequate. The chemistry of seawater itself was turning hostile to life as they knew it. Dead matter piled up quickly in the aftermath, accumulated faster than it could be processed. Fish died in vast numbers, their bodies floating or sinking. Plankton disappeared by the trillions. Marine reptiles succumbed to starvation. Many organisms died in the initial violence, in the heat and pressure and tsunamis. Their bodies sank into deeper layers of water, drifted down through the water column. In ordinary times, scavengers and decomposers would recycle this bounty, would break it down and return nutrients to the system. But the sheer volume overwhelmed them, exceeded their capacity to process. Bacteria feasting on the dead, breaking down organic matter, consumed enormous amounts of oxygen in the process, using it up faster than it could be replenished. They left behind zones of anoxia, areas of water with little or no oxygen at all, dead zones. These anoxic areas spread like stains across shallow seas and into deeper basins, expanding from the coasts. Anything that wandered into them suffocated, died gasping. Fossil layers today, millions of years later, show whole schools of fish entombed in silt, their bodies preserved, their gills flared open in death, caught in the moment when oxygen vanished and they could no longer breathe. The surface of the ocean may have looked deceptively calm at times, waves rolling under a dim sky, but below the surface was chaos, was death spreading in every direction. Some regions teemed briefly with bacteria that thrived on decay, that could operate without oxygen, creating toxic byproducts like hydrogen sulfide as they metabolized. These poisons bubbled upward from the depths, making shallow waters deadly, toxic to anything that breathed oxygen. Reefs, once bustling with fish and invertebrates, once among the most diverse ecosystems on the planet, collapsed into silence. Corals bleached and died as their symbiotic algae perished, as the partnership that had sustained them for millions of years broke down. They left behind only skeletal frameworks, white bones of reef that crumbled without the living animals that built and maintained them. Whole ecosystems that had taken millions of years to assemble, that represented countless generations of growth, unraveled in weeks or months, came apart as if they had never existed. And yet the ocean was not completely empty, was not entirely dead. Survivors endured in pockets, though often in unexpected forms, in species that seemed unlikely to make it. Crocodiles that had ranged into brackish waters, that could tolerate both salt and fresh water, clung to survival in river estuaries and coastal areas. Turtles, with their hardy shells and flexible diets, their ability to eat almost anything, weathered the storm better than many others, found ways to persist. Sharks, those eternal opportunists that had survived previous mass extinctions, found ways to persist despite everything, though their numbers shrank drastically and many lineages disappeared. Tiny plankton species, some adapted to low light or to feeding on detritus rather than producing their own food through photosynthesis, slipped through the bottleneck of extinction, survived when their larger relatives perished. The ocean was strange, transformed beyond recognition, but it was not entirely dead, not quite. Imagine drifting in a boat above those waters if humans had been there to witness it, if we could somehow observe that ancient catastrophe. The surface would have seemed dull, lifeless, gray under the dim sky that never fully brightened. But the smell rising from the ocean would have been wrong, deeply wrong. The tang of salt that normally dominates ocean air would be mixed with a stench of rot and sulfur, unmistakable signs of the death accumulating below, of ecosystems breaking down. Birds, those few small survivors of the dinosaur lineage, might have skimmed the surface desperately in search of scraps, of anything edible. But the great flocks of pterosaurs that once dove spectacularly into schools of fish were gone forever, their aerial acrobatics never to be seen again. The silence above the waves matched the emptiness below, a quiet that spoke of loss. The strangeness of the oceans, the chemical and biological disruption, did not fade quickly, did not resolve in months or even years. The darkness lingered in the atmosphere for years, and with it, the lack of photosynthesis continued. Even when light began to filter back through the thinning ash, when conditions started to improve, recovery was uneven and unpredictable. Some regions, areas flushed by upwelling currents that brought nutrients from the deep, bloomed briefly with new plankton growth, with explosions of life. But these blooms were unstable, short-lived, collapsing almost as soon as they began because the ecosystem structures weren't there to support them. Without stable food webs, without the complex relationships that had been destroyed, larger creatures could not return in force, could not re-establish populations. The ammonites, so successful for so long, survivors of previous extinction events, never recovered from this one. They disappeared completely, vanished from the fossil record above the boundary. Coral reefs rebuilt only in fragments, in scattered locations, taking millions of years to recover anything resembling their former glory. Entire families of marine reptiles, groups that had dominated ocean ecosystems, were gone for good, leaving empty niches that would eventually be filled by entirely different creatures. The ocean had been reset, its former richness stripped away by darkness and chemistry, by starvation and suffocation. When scientists study this period today, when they examine rocks and fossils from the aftermath, they find signs of the strangeness preserved in chemical traces, in isotopes and elements. Layers of clay enriched with iridium, the asteroid's calling card, sit above sediments marked by sudden changes in carbon isotopes, clear evidence of disrupted cycles of carbon and oxygen, of systems breaking down. Fossil shells from this period show pits and etching, physical scars of acidified seas eating away at calcium carbonate. Black shales in the rock record mark anoxic conditions, the handwriting of dead zones that spread like bruises across the world's waters, zones where nothing could breathe. These records are not abstract, not just data points. They are the testimony of an ocean in shock, of marine ecosystems collapsing, preserved for us to read millions of years later. And yet from that shock, from that breakdown, new forms would eventually rise given enough time. Tiny plankton species that endured, that made it through the bottleneck, became the ancestors of modern groups that dominate today's oceans. Sharks, though diminished and reduced, adapted and diversified again over millions of years, evolving into the hundreds of species we know today. Turtles, spread into niches left vacant by the collapse of marine reptiles, took advantage of the opportunities. Birds that hunted fish, descendants of small feathered dinosaurs, became the new aerial predators above the waves, replacing the pterosaurs. Slowly, painfully slowly, the ocean stitched together new patterns of life, rebuilt their food webs and ecosystems, though they bore little resemblance to what had been before, were fundamentally different. It is unsettling to think how fragile the oceans proved to be, how vulnerable. Even though they seem vast and eternal to us, covering most of the planet's surface, a single event, a single impact lasting only seconds, was enough to unravel them almost completely, to bring them to the edge of becoming lifeless. Their recovery took millions of years, required countless generations of evolution and adaptation. But without that unraveling, without that catastrophic reset, the seas we know today with their modern reef systems, with their diverse schools of bony fish, with their whales and dolphins that would evolve much later, would not exist in their current forms. The strangeness of the oceans after the impact, the chemical disruption and biological collapse, was the crucible in which new futures were forged, in which new possibilities emerged. The ocean turned strange, transformed in ways both visible and invisible, not in silence but in a kind of terrible transition. It was not the end, though it must have felt like it to the creatures drowning in darkness and poison, struggling in waters that could no longer support them. It was a passage, a reshaping, a clearing of the slate that was brutal but also creative in its destruction. And when light finally returned to the surface waters, when photosynthesis could resume, it revealed oceans no longer ruled by ammonites or mosasaurs, no longer dominated by the creatures that had thrived for so long. But they were oceans ready for something new, ready for different forms of life, something waiting in the wings of evolution to take the stage. The giants had fallen on land and in the sea. The seas had turned strange, hostile, transformed. And the earth itself seemed broken open by the weight of disaster, fractured by violence. But amid the silence, amid the endless night and the cold that followed, amid what seemed like total catastrophe, life did not end completely. It bent under the pressure. It shrank to fit into smaller spaces. It retreated into corners, into shadows, into places overlooked by the catastrophe sweeping above. The survivors of this long catastrophe, the organisms that made it through, were not the lords of the world, not the dominant species that had ruled for millions of years. They were small, seemingly fragile, easily overlooked. But in their smallness lay resilience that the giants lacked, and in their resilience lay the seeds of the future, the promise of recovery. These tiny survivors, unnoticed in the grandeur of the Cretaceous world, dismissed as insignificant, carried the story of life forward into an uncertain future. They were the inheritors by default, the ones who would rebuild from the ashes. Picture the world in those dark years after the impact. The forests are gone, burned to black sticks and buried under thick layers of ash. The plains are barren, stripped of all vegetation. The rivers are clogged with debris and sediment. The oceans are dim and sour, hostile to most life. But dig into the soil, push aside the ash, and you will find burrows, twisting tunnels carved by mammals that had lived in secrecy for millions of years, hidden from the dinosaurs above. These creatures were no larger than modern rats or shrews, tiny by any standard. They scurried at night to avoid predators, ate insects and seeds and roots, anything they could fit in their small mouths. Their lives had been small, constrained, because they had to be small, because the dinosaurs had ruled the open spaces and the daylight hours, had claimed every visible niche. But when the asteroid fell and the dinosaurs faltered, when the giants began to disappear, the smallness of these mammals became their shield, their protection. A small body needs less food, can survive on scraps that would starve a giant. A burrow provides shelter from fire, from cold, from predators, offers protection. A flexible diet, the ability to eat roots one day, insects the next, carrion when available, seeds when nothing else can be found, offers options when one source of food vanishes completely. Where a hadrosaur needed tons of plants each season just to maintain its weight, a mammal could make do with whatever scraps remained. Where a tyrannosaur needed vast hunting grounds and abundant prey, a mammal could survive in a single valley, could make a life in a tiny territory. The catastrophe was a storm that swept across the world. But storms spare those who are hidden deep enough, those who can wait it out underground. These mammals, blind to any idea of their own destiny, unaware of the future they were creating, endured simply because they were built for obscurity, optimized for survival in the margins. Seeds played a critical role in survival, became lifelines when nothing else remained. In the darkness of the impact winter, when the sun was blocked and plants could not grow, could not photosynthesize, their seeds remained viable in the soil, sealed in tough protective shells. Designed by evolution to wait, they persisted. Mammals cracked them open with sharp teeth, with jaws designed for processing hard foods, drawing on the energy stored within, energy that plants had intended for future generations. Birds did the same, especially those lineages that had already evolved to specialize in seed eating. Their strong beaks, perfectly adapted, could crack even the toughest shells. Crops of cultivated grain did not exist then, but nature's storehouses were scattered everywhere if you knew where to look. Cones from conifers, nuts from various trees, seed pods from countless plants, all buried under ash, waiting. Each seed that was eaten was a meal that carried a body one day closer to the slow return of the light, one day closer to survival. Insects, too, became lifelines, crucial food sources. Many species perished in the fires and cold, populations crashing. But detritivores, those species that fed on decay and dead matter, thrived in the abundance of death that surrounded them. Beetles laid their eggs in carcasses, their larvae developing on rotting flesh. Worms wriggled through rotting plants, breaking them down. Flies multiplied where bodies fell, their populations exploding. For mammals, for the few lizards that survived, for birds, these swarms were food, squirming packets of protein and energy drawn from the collapse itself, from death transformed into life. Insects are often overlooked in stories of survival, dismissed as minor characters. But in that time, in those dark years, they were among the most important organisms on the planet. They were the gears still turning when all else had ceased, the engine still processing when everything else had stopped. They broke down the dead and recycled nutrients, kept ecosystems from stalling completely, maintained some semblance of function. And they fed the survivors who waited out the night, who persisted in their burrows and nests. Reptiles as a group fared poorly compared to mammals and birds, suffered higher extinction rates, but some lineages held on against the odds. Crocodiles, for example, endured in rivers and lakes where others failed. Their bodies are built for patience, for waiting. They can slow their metabolism dramatically, enter states of dormancy, surviving long stretches without food that would kill most creatures. They hide in water that buffers against both extreme heat and cold, that provides stability. They eat almost anything, fish when available, carrion when that's all there is, even each other if pressed hard enough by hunger. When the world collapsed around them, when food became scarce, crocodiles did not need much to persist. They simply waited, half buried in mud, their eyes and nostrils above the surface, conserving energy while chaos raged around them. Turtles did much the same, employed similar strategies. Their shells protected them from many dangers. Their slow metabolisms, their ability to reduce their energy needs, bought them time. And their flexibility with diet, their ability to switch between plants and animals, carried them through the worst. Amphibians too clung on where they could, though their survival was uneven, patchy. Frogs, salamanders, and their kin survived best where water remained liquid year-round, where streams trickled beneath ice, or where geothermal warmth kept ponds from freezing solid, where temperatures stayed above lethal levels. They ate insects when available, detritus when necessary, algae when it grew, whatever remained in their shrinking habitats. Their small size and quick reproductive cycles, their ability to produce many offspring quickly, gave them a chance to rebuild populations quickly once conditions improved, once the recovery began. Birds, the true surviving dinosaurs, the living legacy of that great lineage, were among the most important of the tiny survivors in terms of ecological impact. Not all birds made it through. Many lineages disappeared forever. The toothed birds, primitive forms that still resembled their larger dinosaur ancestors, perished in the catastrophe. But the lineages that could eat seeds and insects, that had the right adaptations, persisted through the darkness. Small bodies that didn't require massive amounts of food. Feathers for insulation against the cold. The ability to fly to find scarce food scattered across wide areas. All of these traits combined to give them a fragile but real edge, a slight advantage that made the difference. From those survivors, from those few lineages that made it through, came every bird we know today, all 10,000 plus species. From sparrows to eagles, from penguins adapted for swimming to parrots with their incredible intelligence. Their songs millions of years later, the dawn chorus and evening calls, are echoes of the resilience that carried them through the darkest of times, through years when survival seemed impossible. In the oceans, survival was harder, extinction rates higher. The collapse of plankton-based food chains wiped out whole groups without mercy. But some small creatures endured in scattered refuges. Tiny plankton species with unusual metabolisms, with adaptations that let them survive without light, managed to feed on detritus instead of photosynthesizing, scavenging in the darkness. Small fish and crustaceans that could eat anything, true generalists that consumed detritus, bacteria, tiny survivors, hung on in isolated patches where conditions happened to be slightly better. Sharks with their efficient bodies honed by hundreds of millions of years of evolution, and their opportunistic diets survived in diminished numbers, their populations crashes but not extinct. Turtles again bridged the gap between land and sea, their shells protecting them as they drifted through seas that no longer welcomed the giants that had ruled. What all these survivors shared, what connected them across different habitats and taxonomic groups, was not strength in the sense of power or dominance, but strength in the sense of adaptability, of flexibility. They were generalists, able to switch strategies. They could hide when necessary. They could wait out bad conditions. They could make do with little with scraps. In a stable, abundant world in times of plenty, specialists often thrive, can outcompete generalists in their particular niches. Dinosaurs that evolved to eat only one specific kind of plant, marine reptiles that evolved to chase only one kind of prey. These specialists dominated. But in catastrophe, when conditions change faster than evolution can respond, specialists collapse. Their narrow adaptations become death sentences. It is the generalists, the flexible, the small, the patient, who inherit what remains, who carry life forward. Imagine walking through that world if you could somehow be transported back, if you could witness it firsthand. You walk carefully through a forest that is no longer green, no longer alive in any recognizable way, but black and gray, a landscape of death. The trunks of trees stripped of leaves, bark, standing like monuments to what was lost. The ground soft with ash instead of grass, each step raising small clouds of gray dust. The sky above is not blue, will not be blue for years, but a dim, heavy gray without a sun to guide you, without stars visible at night. The air smells of sulfur, sharp and choking, a smell that permeates everything. You cannot see the horizon clearly because the haze dulls every distance, flattens perspective. And in the profound silence, there are no birds calling because they are rare and quiet, no insects buzzing in the numbers that once filled the air, no rustle of leaves in the wind because there are no leaves left. Only the soft fall of ash, constant and quiet, like snow that never melts, that only accumulates day after day. But beneath the soil, invisible to casual observation, there is movement, there is life persisting. A mammal scurries from its burrow in the twilight, moves quickly to minimize exposure, to chew briefly on a root it has located. A bird, small and drab, pecks at seeds scattered in the ash, finds nourishment. A crocodile slides silently through a stream, its movements economical, conserving energy. A beetle crawls methodically over a carcass, its mandibles busy breaking down tissue, performing its ancient role. The earth looks dead from a distance, appears lifeless. But it is not dead, not quite. It is holding its breath, waiting. And its breath is carried by the tiny, the overlooked, the survivors. The fossil record preserves this truth with remarkable clarity, tells this story in fragments scattered across the world. The iridium-rich clay that marks the boundary between the Cretaceous and Paleogene, that thin line visible in rock faces from Montana to Spain to New Zealand, holds fragments of these survivors embedded in it. Tiny teeth of mammals, no bigger than grains of rice. Fragile bones of early birds, delicate and easily overlooked. Shells of turtles, their distinctive patterns preserved. scales of crocodiles pressed into sediment, impressions of insects, their bodies leaving faint traces. Above that boundary layer, above that line marking catastrophe, the great bones of dinosaurs vanish almost completely, disappear from the record with only rare exceptions. But these small traces multiply, become more common, diversify. They are the bridge across extinction, the physical evidence that life did not stop, that continuity was maintained. Only the center of gravity shifted, moved from the large to the small, from the specialized to the adaptable. And from these survivors, from these tiny creatures clinging to existence, the future opened like a flower after rain. Mammals, no longer constrained by giants looming above them, no longer forced to hide and scurry, began to grow over millions of years, to spread across landscapes, to experiment with new forms and strategies. Birds diversified into the skies once filled by pterosaurs, claimed every aerial niche from soaring predators to tiny hovering nectar feeders. Crocodiles and turtles continued their slow persistence, their ancient strategies, unchanged in many fundamental ways because what worked in catastrophe continued to work afterward, proved timeless. Insects flourished explosively in the renewal of plants, their populations rebounding as vegetation returned, their diversity expanding. Each group carried forward traits that had been proven in the crucible of disaster, adaptations tested by the harshest conditions Earth could offer. It is humbling to realize, truly sobering to understand, that our own story begins here with these tiny survivors scurrying through ash. Without them, there would be no mammals to evolve into primates millions of years later, no primates to evolve into apes, no apes to give rise to humans. Without them, the world would have been reset into something entirely different, would have followed a completely different evolutionary trajectory. Perhaps it would have been dominated by reptiles that endured, by crocodilians or turtles expanding into new forms. Perhaps by strange survivors we cannot even imagine, lineages that might have emerged from the chaos. But because these particular creatures survived, because mammals and birds made it through, our lineage exists. Every breath we take is linked to the teeth of those tiny shrew-like mammals gnawing seeds in the darkness, to the feathers of those seed-eating birds waiting for dawn, to the patience of those crocodiles in muddy rivers conserving their energy. They endured, and so we exist, our entire history built on their survival. The giants ruled with spectacle, with size and power that commanded attention and awe. But it was the hidden, the overlooked, the tiny and insignificant that ensured life continued, that maintained the thread across catastrophe. In the end, survival was not about being the strongest or the most fearsome, not about size or dominance. It was about fitting through the narrowest cracks of fate, about being small enough to hide, flexible enough to adapt, patient enough to wait. The mammals in their burrows pressing together for warmth, the birds cracking seeds with specialized beaks, the beetles processing carrion in the darkness, they slipped through the bottleneck of extinction, carrying life's story across an abyss that swallowed the giants. And when the light returned, when it finally broke through the veil of ash, slowly and painfully over months and years, these tiny survivors emerged into a world empty of giants but full of opportunity, full of vacant niches waiting to be filled. They were small, yes, almost insignificant by the standards of the world that had been. But they were alive, and that was everything. That was enough to start again, to rebuild, to create something new from the ashes of the old. The earth was not silent only in its animals, not muted only by the loss of dinosaur calls and pterosaur wingbeats. The impact, the fires, the darkness, and the cold had also reached deep into the green fabric of the planet, had touched the foundation of terrestrial ecosystems. Forests had burned to skeletons, their magnificent canopies reduced to ash. Plains had emptied of their grass and flowers. And the very engine of life, the process of photosynthesis that had powered ecosystems for hundreds of millions of years, had gone quiet, shut down by darkness. Plants, which had painted the earth with color and life for so long, seemed to vanish almost overnight in the immediate aftermath. Their stems withered without light. Their leaves turned brittle and fell. Their flowers never opened, their petals remaining closed as if waiting for a sun that would never shine brightly again. But plants are not only what we see above the ground, not only the visible stems and leaves and flowers. Beneath the ash and frozen soil, hidden from view in roots and seeds, something remained, something waited with infinite patience. What looked like death from the surface was not final, not absolute. It was dormancy. It was potential waiting for its moment. In those first months after the impact, the months of deepest darkness, the ash that fell was thick enough to cover entire landscapes in layers several centimeters deep in many places. It blanketed valleys, choked rivers with sediment, and smothered what few green shoots had somehow survived the initial fires. Rain mixed with ash to form a gray paste that clogged the surface, created a barrier. For many plants, for countless species, this was indeed the end. They had no sunlight to power photosynthesis, no clear air to breathe, no strength left to push through the heavy blanket above them. Whole forests, ancient lineages of trees that had existed for millions of years, disappeared in that moment, unable to endure even a season without light, without the energy they needed. But other species, had prepared for harsh times long before the asteroid arrived, had evolved strategies for endurance. Seeds, tough and resilient, carried the genetic memory of their species, the blueprint for regeneration. Some could remain dormant for months, others for years, even decades in some cases, waiting patiently for the right conditions. Warmth, water, and most critically, light. Seeds are one of evolution's simplest but most powerful strategies for survival, perhaps the most elegant solution to uncertainty. They are capsules of life, tightly packed with energy in the form of starches and oils, and instructions encoded in DNA, designed by millions of years of evolution to survive the uncertainty of the world, to bridge gaps in favorable conditions. In the Cretaceous, plants had already perfected this strategy through countless generations of selection. Conifers dropped cones filled with seeds built to endure cold winters and hungry animals, protected by tough scales. Flowering plants, angiosperms, scattered pods and nuts, some armored against fire and frost with thick protective coats, some small enough to disappear into soil cracks and wait unseen for years. These seeds were the hidden army of life, an invisible reserve lying in silence beneath the devastation, waiting for their chance, for conditions to improve. Roots, too, told a story of patience and preparation. Many plant species store energy below ground in specialized structures. Tubers, bulbs, rhizomes, or thick root systems designed for survival. Even if their stems and leaves above ground were destroyed completely, burned or frozen or buried, these hidden parts could survive, could remain dormant in the cold soil, insulated by layers of earth, ready to send up new shoots when conditions finally improved. It is quite possible that entire landscapes we thought had been erased, that appeared completely dead, carried this underground memory, a hidden storehouse of potential beneath every square meter of ash, waiting for the signal to grow again. In the earliest months after the impact, during the deepest darkness when the skies were black and the ground was frozen, none of this waiting was visible to any observer. The earth looked utterly barren, completely lifeless. The gray ash covering everything suggested total death, complete sterilization. But as the years passed slowly, as light gradually began to return and filter through the thinning atmosphere, as temperatures moderated slightly, the first green appeared. And remarkably, it came not from new creation, not from life arriving from elsewhere, but from the seeds and roots that had endured underground, that had waded through the worst. Scientists find this story of patient survival written clearly in fossilized pollen, preserved in sedimentary rocks. At the boundary layer that marks the impact, at that thin line of iridium-rich clay, pollen grains suddenly vanish from the record, a dramatic drop in diversity. This is evidence of plants wiped away en masse, of forests and meadows disappearing. But just above that barren layer, new pollen appears in the sediments, first in small amounts, then increasing. First from ferns, those ancient plants, then from conifers, then from flowering plants. This pattern, this sequence of recovery, is found worldwide. The fern spike, as paleobotanists call it, is one of the most distinctive signatures of the extinction, a marker found globally. It represents the sudden dominance of fern spores in the fossil record immediately above the boundary, a spike in their abundance. This is the signature of resilience, the calling card of survival. Ferns, whose spores are tiny and incredibly hardy, able to survive harsh conditions, were often the first to recolonize landscapes after catastrophe throughout Earth's history. Their spores could travel on the wind for thousands of miles, could wait in the soil for years, could germinate quickly when conditions improved. They painted the earth in green again, thin and fragile at first, carpeting vast areas, but undeniable evidence that life was returning, that the planet was healing. The return of plants was uneven across the globe, patchy and unpredictable. In some places, ferns dominated for decades, creating landscapes of low green fronds carpeting ash fields that had once been forests. In others, shrubs and grasses pushed through first, their seeds germinating in disturbed soils, taking advantage of the lack of competition. Trees returned much more slowly, their establishment requiring more time, more stability, deeper soil, and more consistent conditions. Their seeds needed time to germinate. Their seedlings needed years to establish root systems deep enough to anchor them. But once they did take hold, once they survived those critical early years, the forests began to reassemble themselves gradually, though in completely new configurations, in patterns that had never existed before. Entire lineages of trees that had flourished before the impact, that had dominated Cretaceous forests, never returned, their seeds having failed to survive or their environmental requirements no longer being met. Others, species that had been minor players in the pre-impact world, seized the empty niches and spread rapidly, became dominant where they had once been rare. Recovery was not simply regrowth, not a return to what had been. It was reshaping. It was the creation of something new from the remnants of the old. Imagine walking across one of these early recovering landscapes, a decade or two after the impact, after the worst of the darkness had lifted. The ground is still predominantly gray and broken, scarred and lifeless in appearance. But here and there, increasingly, small patches of green catch your eye, draw your attention like beacons of hope. Ferns unfurling their delicate fronds, their bright green startling against the ash, beautiful in their simplicity. Shrubs pushing upward with stubborn shoots, defying the desolation. Grasses waving in thin clusters, their blades catching what light filters through. The air, while still carrying traces of sulfur and dampness from the disturbed chemistry, now carries a hint of something else, a hint of green, of chlorophyll, of photosynthesis resuming. It's faint, subtle, but real, unmistakable. Birds, those small survivors, flit among the patches of vegetation, feeding on seeds and insects, their presence a sign of returning complexity. Mammals scurry carefully through the undergrowth to nibble on shoots, to test this new food source. Insects, their populations rebounding, crawl over the first flowers that dare to bloom. Slowly, almost imperceptibly, a new rhythm begins to establish itself, the ancient rhythms of life reasserting themselves. The patience of plants was more than just a story of seeds and roots waiting passively, more than simple dormancy. It was a story of evolutionary strategy, of adaptations refined over hundreds of millions of years. Some species had always lived in environments characterized by cycles of fire and flood, by periodic disturbances, and had evolved the ability to bounce back quickly after catastrophe, had been shaped by instability. In the chaos after the asteroid, in a world suddenly defined by disturbance on a global scale, these species had the advantage, were pre-adapted for the conditions. Ferns with their quick reproductive cycles and hardy spores that could colonize bare ground spread first, claimed the empty spaces. Grasses with their low growth points, protected from grazing and cold and fire, flourished where forests had once stood, turned ash fields into meadows. Shrubs and small trees grew rapidly where the soil had been scoured, where competition was minimal. Over time, measured in centuries and millennia, larger trees followed in succession, gradually shading the ground, creating habitats for other life, building structure. The forests of the Paleogene, the epoch that followed the Cretaceous, were not copies of the old forests, not recreations. They were mosaics shaped by the waiting of plants, and shaped equally by the absence of those lineages that had not endured, that had failed to make it through. The waiting was not passive in any sense, not merely endurance. Seeds had evolved chemical defenses to deter animals from eating them, compounds that made them unpalatable or toxic. They had hard coats to resist decay, to prevent fungi and bacteria from breaking them down. They had mechanisms, often complex, to sense light and moisture, to know when conditions were right for germination. Roots had energy reserves stored carefully in the form of starches and sugars, fuel for regrowth. Plants had prepared for hardship without conscious knowledge, shaped by the grinding selection of evolution over millions of years. And when the world collapsed, when everything seemed lost, these preparations became salvation, became the difference between extinction and survival. The Earth's green mantle shrank drastically to its hidden parts, to seeds and roots invisible beneath ash. But it did not vanish entirely, did not blink out. And when life returned above ground, when green shoots finally pushed through gray ash, it changed the world again, began to rebuild the foundation. Plants do not simply decorate landscapes, do not merely add color. They create landscapes, shape them, define them. Their roots hold soil in place, prevent erosion, create stability. Their leaves shape the water cycle through transpiration, releasing moisture into the air. Their bodies, living and dead, fuel herbivores and decomposers, form the base of food webs. When plants reappeared after the impact, even in small scattered patches, even in reduced numbers, they drew animals back to the land, created opportunities. Insects returned in increasing numbers to feed on leaves and pollen, to resume their ancient relationships. Birds followed the seeds, the insects, the returning abundance. Mammals gnawed on the roots and shoots, supplemented their diets with this new green food. Reptiles basked in the thin shade cast by recovering shrubs, used the structure for shelter. Each green shoot was not only survival for the plant itself, but a beacon that called others to return, an invitation to rebuild community. In time, measured in thousands and millions of years, forests grew again in full complexity, though different from before, transformed. Palm trees spread in warm regions, adapted to the new climate patterns. Deciduous trees, those that lose their leaves seasonally, expanded into new spaces, claimed territories. Flowering plants, angiosperms, diversified explosively, experimented with countless new forms that would one day produce the fruits, nuts, and flowers we recognize today, that would shape the modern world. These plants carried forward the memory of waiting in their evolutionary strategies, encoded in their genes. Fast growth to colonize quickly. tough seeds to survive disturbance, flexible reproduction to maximize success. Their patience through the catastrophe had shaped their resilience, refined their strategies, and their resilience in turn shaped the recovery of life across the planet, determined which animals could return and where. Without the plants that waited, without those seeds lying dormant and those roots clinging to life underground, there would have been no foundation for animals to return to, no food web to support recovery, no seeds for birds to crack open, no roots for mammals to dig up, no leaves for insects to consume, no forests to shelter new ecosystems as they assembled. The world might have remained barren far longer, its recovery stalled indefinitely, a gray wasteland persisting for geological ages. But because seeds lay hidden in their protective shells, because roots clung to life in the soil, because the genetic information and energy reserves persisted, the green returned when light finally broke through. It may have been fragile at first, patchy and sparse and strange, but it was enough to start the process. It was the beginning of renewal, the first step on a long journey back to abundance. Even today, millions of years later, you can see the legacy of that patience written in plant strategies worldwide. When forests burn in wildfires, devastating regions, ferns are often the first to return, sprouting from spores that waited in the soil through the fire, through the heat. After volcanic eruptions bury landscapes in thick layers of ash, creating seemingly lifeless moonscapes, grasses and shrubs appear within just years, their seeds having survived burial or arrived on the wind. Seeds endure in soil seed banks, buried reserves, waiting decades or even longer for the right conditions, for disturbance to create opportunity. The strategies that carried plants through the asteroid catastrophe, through the worst extinction event they ever faced, are the same fundamental strategies that let them recover from disasters now, that make them resilient. They are quiet strategies, invisible most of the time but powerful beyond measure. The animals that survived the extinction, that made it through the darkness and cold and starvation, carried forward profound gifts from these plants, dependencies that would shape all future evolution. Birds evolved increasingly sophisticated specializations for seeds, fruits, and nectar, their beaks and digestive systems adapting. Mammals developed diets tied intimately to the new flowering plants that dominated the recovery, their teeth and guts evolving to process this food. This relationship shaped the rise of primates millions of years later, frugivores living in flowering tree canopies, and eventually shaped humans, omnivores dependent on plant agriculture. The entire trajectory of life, the path evolution would follow, was redirected by the patience of plants, by their ability to wait through catastrophe. The green shoots that pushed through the ash in those early years of recovery were not only survivors in a passive sense. They were architects of the new Earth, engineers rebuilding a broken world. And so, while the story of the asteroid is often told primarily as the end of the dinosaurs, as a tale of extinction and loss, it is equally and perhaps more importantly the story of seeds, roots, and spores that refused to die, that held on through impossible conditions. The plants that waited in silence beneath the ash ensured that life would not end in permanent darkness. They gave the animal survivors food, shelter, and a foundation to build upon, resources to reconstruct ecosystems. They turned devastation into renewal, death into life, ending into beginning. The world that emerged from their patience, from their stubborn refusal to surrender, was not the same as the one that had been lost. It could never be the same. It was younger in a sense, stranger in its configurations, more open to experimentation and novelty. It carried the scars of the catastrophe in its soil and rocks, visible to those who knew how to read them. But it also carried the promise of diversity, of new relationships of different forms. The plants that waited did not just endure passively. They shaped everything that came after, determined what was possible, created the stage on which the drama of mammalian evolution would unfold over the next 66 million years, leading to our present. The giants were gone, their bones settling slowly into ash and mud, becoming fossils, their shadows fading from a world that no longer belonged to them, that had moved on. The forests had begun to stitch themselves back together painfully, slowly. Cautious green pushing through gray soil like hope emerging from despair, ferns unfurling their ancient fronds, grasses stretching toward weak sunlight, shrubs reclaiming the empty spaces one patch at a time. Birds flitted above in increasing numbers, their calls returning to the air. Insects buzzed again in growing swarms. Rivers carried life in their currents once more. In the silence that followed the catastrophe, in the quiet after the storm, new voices were waiting to be heard, waiting for their moment. Among the creatures that had hidden in burrows through the worst times, that had scurried underfoot unnoticed for millions of years, that had survived on seeds and insects and patience, there was a lineage ready to take its turn on the world stage. Small, unnoticed, seemingly insignificant in the age of dinosaurs, the mammals were about to step out of the shadows into the light, were about to claim the world the giants had left behind. The age of mammals had begun, though no one could have predicted the forms they would eventually take. For more than 150 million years, an almost incomprehensible span of time, mammals had been minor players in Earth's drama, supporting characters at best. They had shared the Earth with dinosaurs, coexisted in the same ecosystems, but never as equals, never as rivals for dominance. Most were small, no bigger than modern rodents, barely noticeable. They darted through the undergrowth, lived primarily by night to avoid predators, avoided the giants who ruled the open land by day with unchallenged authority. Their diets were humble, unremarkable. Insects gleaned from bark and soil, seeds gathered and cached, roots dug from the ground, eggs stolen when opportunity arose. Their lives were hidden, lived in the margins, burrows underground, nests in hollow logs, cracks in rocks barely large enough for their small bodies. They were clever in their obscurity, successful in their own way, but the world had not offered them the chance to grow larger, to expand into new forms and sizes, to experiment with different strategies. Every niche seemed filled, every space taken by reptiles far more massive and dominant, by creatures that had claimed the world. But then the asteroid struck with world-ending force, and everything changed overnight in geological terms. In the aftermath of impact, during the long darkness and cold, size became a burden instead of an advantage, a liability that couldn't be supported. Specialization became a trap that couldn't be escaped, leading to starvation when conditions changed. What had once made the dinosaurs strong, their size and their refined adaptations, now condemned them to extinction, sealed their fate. What had made mammals overlooked and seemingly insignificant, their small size, their generalist diets, their tendency to hide and wait, became precisely the traits that allowed them to survive the unsurvivable. And survival in that dark world of ash and cold, in that transformed planet, was everything, was the only thing that mattered. The earliest mammals to emerge into the Paleogene, to inherit the post-impact world, were tiny compared to what we imagine when we think of later mammals, of the giants that would eventually evolve. Most weighed no more than a pound or two at most, no larger than modern rats or shrews. Some were dedicated insect eaters, their sharp teeth perfectly designed for slicing through beetles and larvae that still swarmed among the rotting landscapes, that thrived on death. Others were seed crackers, their jaws surprisingly powerful for their size, strong enough to break into the hardened stores of plants that had waded through the darkness in protective shells. A few were true omnivores, willing to try anything available, flexible enough to switch strategies. They would eat roots when they could find them, carrion when they stumbled upon it, eggs if they could raid a nest, even each other if the famine grew too dire, if no other option presented itself. In these harsh years, during the difficult recovery, adaptability was not a luxury or a nice bonus. It was the line between life and death, between continuation and extinction. Fossils tell us through their silent testimony that mammals diversified quickly after the extinction, explosively by evolutionary standards. In the rock layers above the iridium-rich clay that marks the impact, above that thin boundary line, mammal remains multiply dramatically, increasing in both number and variety. Teeth in particular are found in abundance, and teeth are incredibly informative to paleontologists. Mammal teeth are distinctive, highly specialized, with each shape adapted precisely to a particular kind of diet, revealing how the animal lived. The fossil record shows a sudden burst of dental variety, an explosion of different tooth forms. Sharp cusps for slicing insects and meat, flat surfaces for grinding plants and seeds, mixed patterns for omnivorous diets that included everything. This explosion of dental forms, this rapid diversification, is the fossil signature of opportunity seized, of empty niches being filled. With dinosaurs gone, with food webs collapsed and then slowly rebuilding, mammals seized the open niches, claimed territories and strategies that had been closed to them for millions of years. At first, in the immediate aftermath, the changes were subtle, almost imperceptible. Mammals grew only slightly larger over generations, spreading gradually into sizes that had been dangerous, often fatal, when predators like raptors and tyrannosaurs still hunted the land, when being noticed meant death. They began to experiment cautiously with new behaviors, climbing more frequently to exploit trees, swimming more often to access aquatic resources, digging deeper to find roots and tubers, exploring new ways of living and feeding. Within a few 100,000 years, barely a moment in geological terms, a blink of Earth's eye, the mammal world was far more diverse than it had ever been under the shadow of dinosaurs, more varied in form and strategy. The key to their success, the secret of their rapid rise, was flexibility built into their very biology. A mammal's body is not tied to the environment in the same rigid way a reptile's is, not dependent on external temperatures. Warm-blooded with fur for insulation, mammals could regulate their own temperature internally, maintain stable body heat. They could endure the cold nights of the impact winter, survive in climates that would have immobilized or killed cold-blooded reptiles. Their young were nurtured with milk, a remarkable portable food source that protected infants when external food supplies were scarce or unreliable, that gave offspring a better start. Their brains, larger relative to body size than those of most reptiles, allowed them to learn from experience, to adapt behaviors, to experiment with new strategies rather than relying purely on instinct. All of these traits, relatively insignificant when dinosaurs filled the world and dominated every landscape, became decisive advantages when catastrophe reset the game, when the rules changed overnight. Imagine a landscape perhaps 10 or 20 years after the impact, a world in transition. The air is still dimmer than it was before, still hazier, though light has begun to return in meaningful amounts. The forests are patchy and young, dominated by ferns and shrubs with young trees just beginning to rise toward the sky, still small. Across the ground, mammals scurry everywhere you look, some no larger than mice, others approaching the size of small cats. They dig energetically for roots, using strong claws. They climb with increasing confidence for seeds in low branches. They chase beetles through the leaf litter with focus and determination. Their calls and rustles fill the silence left by the dinosaurs, create new soundscapes. For the first time in more than 150 million years, They are not merely background noise in someone else's story. They are the main story, the primary actors, the creatures that matter most. As centuries passed and turned into millennia, as millennia accumulated into millions of years, mammals continued to grow, to experiment, to push boundaries. Some lineages stretched upward into larger and larger forms, testing the limits of size once again. Herbivores expanded through multiple stages, rabbit-sized, then deer-sized, then eventually into beasts as large as modern rhinos and elephants, giants in their own right though different from the dinosaur giants. Carnivores followed in their wake, evolving in parallel, sharpening their teeth and claws for bigger prey, developing cooperative hunting strategies. In the oceans, too, mammals appeared through a remarkable evolutionary transition. Small land-dwelling mammals began venturing into water, began hunting fish and aquatic invertebrates, beginning the extraordinary journey that would one day, many millions of years later, create whales and dolphins, would return mammals to the sea. Every direction life could explore, every available niche, mammals explored with remarkable speed and creativity. The extinction had cleared the board completely, removed all the major pieces. And mammals were quick to play the new game, to fill every empty space. But this rise was not immediate domination, not instant success without setbacks. The world was still harsh, still recovering from trauma. Climate swings persisted, temperatures fluctuating unpredictably. Food webs remained unstable, prone to collapse. Ecosystems were fragile, easily disrupted. Many mammal lineages that tried to expand, that attempted new strategies, failed and when extinct became evolutionary dead ends. For every success story preserved in the fossil record, there were multiple extinctions, experiments that didn't work. The survivors of the survivors, those that carried forward, were those that balanced ambition with caution, that could adapt quickly to sudden setbacks, that combined opportunism with resilience. The story of the mammals after the impact is fundamentally one of filling space, of expansion into emptiness. Dinosaurs had filled virtually every conceivable role in terrestrial ecosystems over their long reign, from towering herbivores browsing the highest leaves to ground-level grazers, from apex predators to small insectivores, from desert specialists to forest dwellers. With them gone, all those roles were suddenly empty, available. Mammals stepped into every vacancy. They became grazers on the recovering grasslands, browsers in the new forests, hunters of various sizes, scavengers cleaning up carrion, climbers in the trees, swimmers in the rivers, burrowers in the soil. Their bodies shifted remarkably quickly to match these new lifestyles, adapted with surprising speed. Some lineages developed long legs for running across open ground, for speed. Others developed strong claws for digging, for accessing underground resources. Some lengthened their snouts and sharpened their teeth for hunting efficiently, for tearing flesh, while others broadened their molars for grinding plants, for processing tough vegetation. Evolution accelerated dramatically in the absence of competition, in the vacuum left by the dinosaurs. And in just a few million years, an eye blink in Earth's history, the Earth looked entirely different, unrecognizable, transformed. This was the true beginning of the Cenozoic era, the age that continues to the present day, the age of mammals that we still live in. It was not a sudden reign like the dinosaurs had enjoyed, not an immediate takeover, but it was a gradual expansion, a spreading of influence from the shadows and margins into every open niche, into every available opportunity. The mammals were not giants yet in those early days, not impressive in size. That would come much later, after many millions of additional years of evolution, with creatures like the mammoths and mastodons, the giant ground sloths and massive whales. But the foundation was laid firmly in those first fragile centuries after the impact, when survival meant small bodies, quick lives, and endless adaptability, when flexibility trumped every other trait. The mammals were not alone in inheriting the world, of course, not the only survivors. Birds flourished in the skies, their populations rebounding, inheriting much of the ecological space once ruled by pterosaurs, filling the aerial niches. Crocodiles and turtles remained in the rivers and coastlines, living reminders of an older age, ancient lineages that proved their strategies worked across multiple mass extinctions. But it was the mammals who took center stage on land for the first time in Earth's entire history, who became the dominant large animals, who would shape terrestrial ecosystems. Their endurance through the catastrophe, their ability to hide and wait through the worst, their flexibility and adaptability, had given them the key to a kingdom they had never been allowed to enter before, had never been able to claim. Now, step by step, generation by generation, they began to unlock its doors, to explore its possibilities, to make it their own. From these humble beginnings in the ash, from these small creatures scurrying for survival, everything followed over the next 66 million years. The rise of primates from small insectivores into tree-dwelling fruit eaters. The spread of ungulates across grasslands that would come to dominate many continents. The emergence of predators with saber teeth, of massive herbivores, of giants in new forms. The mammals that scurried through ash fields and fern patches immediately after the asteroid, that lived on scraps and patience, could not have imagined what their distant descendants would become, could not have predicted the diversity that would emerge. They only did what all survivors do, what life has always done. They endured. They ate whatever they could find. They bred when possible. But in doing so, in simply persisting, they reshaped the Earth over deep time, redirected the course of evolution. The age of mammals did not begin with grandeur or spectacle, did not announce itself dramatically. It began quietly with tiny creatures living on scraps, peering cautiously out from burrows into a wounded world, testing whether it was safe to emerge. But in their quiet persistence, in their stubborn refusal to give up, was the promise of a new story, one that would carry life forward into forms unimagined, into possibilities unlimited. The dinosaurs had ruled with spectacle and power, with size that commanded awe. The mammals would rise with subtlety and adaptability, with flexibility that proved equally powerful. And in time, over millions of years of evolution, that subtlety would prove just as transformative, just as world-shaping. The age of mammals had begun, tentatively at first but inevitably. And the Earth would never, ever be the same again, would be forever transformed by what emerged from those dark burrows into the slowly brightening world. And so we come full circle in our journey through time, returning to our present moment after walking 66 million years into the past and back again. The asteroid that struck the Yucatan Peninsula with unimaginable force, that ended the age of dinosaurs and transformed our world, was one of the most violent moments in Earth's long history, a catastrophe almost beyond comprehension. But its story is not just about destruction and death, not merely a tale of endings. It is a powerful reminder of how fragile life can be, how quickly stability can shatter, and also how remarkably resilient life proves to be, how stubbornly it clings to existence. It shows us how deeply connected we are to everything that came before, how our very existence depends on events we never witnessed, on survival of creatures we never knew. We began with the day the sky fell, with the moment when a rock from the depths of space tore into the Earth, and ended an age that had lasted over 150 million years. That moment is easy to picture in dramatic flashes of fire and chaos, in explosions and tsunamis. But it is harder, more challenging to picture in its silence in what came after. It was not only an explosion, not just a single moment of violence. It was a long night that lasted years, a cold that settled deep into soil and ocean, a profound loss that rippled across every continent and every ecosystem. Dinosaurs, ammonites, pterosaurs, entire worlds of creatures representing millions of years of evolution, were gone in what must have felt like an instant to those who lived through it. The silence of their absence is what echoes most strongly through the fossil record, what speaks most powerfully to us today. And yet, if we stopped there, if we focused only on the extinction, we would miss the larger truth, the deeper meaning. The story was not only about endings, not solely about death and loss. It was equally about what came after, about recovery and renewal. The mammals that survived were not mighty or impressive, not the creatures you would pick to inherit the world. They were small, timid, often overlooked, barely worth noticing. But when the giants vanished, when the titans fell, those small survivors carried forward the thread of life, maintained continuity across the catastrophe. They were not chosen by any plan, not destined for greatness. They were simply able to bend when the world broke, flexible enough to survive when rigid forms failed. From them came all the diversity of the Cenozoic era, all the mammals we see today. Elephants and whales, bears and bats, primates and humans. From them came the birds that sing outside our windows every morning, the forests that shade our paths, the ecosystems we depend on every single day. If the asteroid had not struck, if that rock had missed Earth by even a small margin, the world would be different today in ways we cannot fully imagine. Perhaps dinosaurs would still rule, would still be the dominant large animals on every continent. Perhaps mammals would still be tiny, furtive creatures, hiding in shadows, never getting their evolutionary chance, never diversifying beyond small body sizes. Our own existence, human existence, is tied intimately to that moment of destruction and recovery 66 million years ago. It is strange, even unsettling, to think of ourselves as children of catastrophe, as beneficiaries of extinction. But in a very real way, we are exactly that. We are here because something ended, because one age closed and another opened. We are here because fragility gave way to resilience, because seeds waited patiently underground, because small mammals knew how to hide, because life found new paths forward when the old ones were blocked, because forests grew again from ash, because survivors refused to surrender. The scar of Chicxulub, buried beneath the Yucatan Peninsula, is not just a reminder of destruction, not merely a monument to extinction. It is equally a reminder that from endings come beginnings, that from the deepest silence can come new songs, that from ashes can rise possibilities never before imagined. That truth is both humbling and hopeful, both sobering and inspiring. It reminds us that nothing lasts forever, that dominance is temporary, but also that life itself is remarkably persistent, astonishingly creative in finding ways forward. As we reflect on this journey through deep time, we also see how much the Earth remembers, how thoroughly it preserves its history. Fossils scattered across the globe, crystals shocked by impossible pressures, clays enriched with extraterrestrial iridium, boundary layers marking before and after. They are all voices of the past, evidence that cannot lie, carrying messages across millions of years with perfect fidelity. They do not exaggerate for dramatic effect. They do not forget inconvenient details. They show us clearly, unambiguously, that extinction is real, that catastrophes can and do reshape the entire planet, that resilience is never guaranteed but is always, somehow, possible. To listen to what the Earth preserves is to learn patience, to understand that change is the only constant, that survival is never simple, that beauty and loss are always intertwined in the story of life. There is also a lesson here for our own time, for the present moment we inhabit. We like to think of ourselves as separate from the creatures that came before, as if intelligence and technology make us exempt from the patterns of fragility and resilience that have governed life for billions of years. But we are not exempt, not special in that way. We are vulnerable to climate shifts that happen too quickly for adaptation, to ecosystem collapse that removes the foundations we depend on, to disruptions in the delicate balance of sunlight and soil and water that makes our existence possible. The asteroid reminds us starkly that stability is fragile, that life depends utterly on forces beyond our control, on cosmic chance and planetary systems. But it also reminds us that resilience is possible, achievable, that survival is never only about strength or size, but about adaptability, about cooperation, about the ability to endure hardship and emerge changed but alive. If an asteroid were to come again, if another rock fell from the sky tomorrow, the story might include us, and we would face the same terrible test the dinosaurs faced 66 million years ago. But unlike them, we have knowledge they lacked. We know what happened before, understand the mechanics of impact. We know the scar of Chicxulub exists, buried and waiting. We know the silence preserved in the fossil record, the story written in stone. We know that small size and flexibility mattered more than strength, that generalists survived where specialists perished. That knowledge is itself a form of resilience, a tool the dinosaurs never possessed. It is a chance to prepare, to adapt, to look beyond ourselves and our immediate needs. Awareness does not erase fragility, does not make us invulnerable, but it gives us tools to face uncertainty, possibilities the dinosaurs never had. And so, as we close this journey through Earth's memory, we return to the image of the sky, to the vault above us. Once it fell, turned against life with fire and darkness. Once it darkened for years, blotting out the sun that powers everything. Once it was filled with fire and ash and the debris of destruction, raining down molten rock. But it cleared eventually, inevitably. The sun returned, weak at first, then stronger. Forests rose again from buried seeds. Life spread once more across the scarred continents, filled the recovering oceans. The sky today, the one we see when we look up, is the same sky that once carried debris from Chicxulub around the entire globe. The same sky that once glowed with returning fire. The same sky that darkened for years and then slowly, painfully cleared. When you look at it, when you pause to really see it, you are looking at both fragility and resilience, at both endings and beginnings, at both the possibility of catastrophe and the promise of recovery. We are part of that story whether we realize it or not, whether we think about it or not. Every bird in the sky is a descendant of dinosaurs that endured, that survived against impossible odds. Every tree in the forest is part of a lineage that survived fire and ash, that waited underground and then pushed through gray soil toward light. Every mammal, including us, including every human being, is here because small creatures once waited in burrows, huddled for warmth and outlasted giants. The asteroid was not the end of life, not the final chapter. It was a turning point, a hinge moment, a transformation. We live in the world it created whether we acknowledge it or not, whether we understand it or not. So, what do we take from this long journey through catastrophe and recovery? What lessons echo across 66 million years? Perhaps a sense of humility, a recognition that we are not immune to forces greater than ourselves, that our civilization is more fragile than we like to believe. Perhaps a sense of gratitude, profound and deep, that we exist at all, that the chain of survival was never completely broken, that we are heirs to resilience older than humanity itself, older than primates, older than most mammals. Perhaps a sense of responsibility, an obligation to treat this fragile, resilient Earth with care, to remember that our future depends on how well we adapt, how well we endure, how well we listen to the lessons written in stone and bone and ash. And with that, Let me thank you sincerely for walking through this story with me, for staying with this journey through deep time. If you found it soothing, if you found it thought-provoking, if it gave you a different perspective on time and existence, consider liking and subscribing to this channel. Because here we speak not only of Earth's beauty and abundance, but of its scars and losses. Not only of what it gives freely, but of what it remembers and preserves. Not only of life's successes, but of its failures and recoveries. Until next time, wherever you are on this remarkable planet, look at the sky above you. Remember its fragility, the thin atmosphere that separates us from the void, and trust in its resilience, in the same resilience that brought life back from the edge of annihilation. After all, it is the same sky that has carried life forward through darkness, through silence, through fire, through the longest night into countless dawns. It is the sky of survivors, of creatures that refuse to surrender, of life that persists against all odds. And we, every one of us, are children of that persistence, heirs to that refusal to end. The day the sky fell was not the end of the world, though it must have seemed so to those who lived through it. It was the end of one world and the beginning of another, our world, the world we inhabit today. And that story, that transformation from catastrophe to renewal, continues still, written in every living thing, in every breath we take, in every moment we exist on this ancient, scarred, beautiful, resilient planet we call home.